Hello. While React.js is great for creating modern user interfaces with ease, it can be tough to know where to begin learning it. While many developers in this day and age know some JavaScript, many are surprised by the depth of knowledge required, even for basic React apps. To make matters more confusing, idiomatic React apps heavily leverage modern ES6 features and even some ES7 features. Finally, to really be productive with React, you must also be familiar with modern front-end build tools as well. My goal with part one of this series is to not only teach you React, but also teach the things you'll need to learn along the way. Great care has been taken to strike the right balance between not taking shortcuts that you have to fill in later, but also not distracting you with endless details. If you have even a passing knowledge of JavaScript and want to learn React the right way, this is the video for you. In lesson one, I show you how to create your own React toolchain using technologies such as Webpack and Babel. I also show you how to leverage createreactapp to bootstrap your development even quicker. Then we cover some advanced JavaScript topics that regularly pop up in React, such as context binding and functional programming. Then you'll learn some modern ES6 features in order to write more idiomatic React code. We will also explore async await. We cover some of the concepts behind React. We take an in-depth look at how React's virtual DOM works. Then we start writing some React code using the original create class syntax and begin to look at JSX. When you see how we can rewrite our earlier code using modern ES6 features. From there, we cover the remaining vanilla React topics, such as component lifecycle and state management. Then we discuss some ways you can tweak performance in React apps. Finally, we explore a number of different ways you can style your React applications. We have a lot of ground to cover, so let's begin.
So one of the most intimidating aspects about programming in React isn't React itself. It's the toolchain and the ecosystem that is required to do any serious React programming. Now, if you want to, over on the React site, you'll see that they have a starter kit that will run your code through some scripts that do most of the lifting for you, including the JSX compilation, where JSX is this little HTML-like syntax that you drop into some of your JavaScript functions. But of course, web browsers can't run JSX directly, so you either have to have a script in your page that will convert it for you, or what people do in production, real-life React code bases, is they will turn that JSX into the equivalent JavaScript version beforehand. Now, as we're busy compiling code anyway at this point, turning JSX into regular old JavaScript, frequently, React developers, being forward-thinking, like to utilize the latest and greatest ES6 features. Now, the problem with using these latest features is often you have to have a pretty modern browser to use it. If you go to Can I Use It, you can see different supports for JS, HTML5, and different features. And while if you have a very modern version of Firefox or Chrome or any other modern web browser, you can use most, if not all of it. By the time this video hits you, it's possible that all the mainstream browsers will have 100% ES6 support. Last I checked, they're at like 99.999. At any rate, most of your users, well, even if most of your users actually are using the latest and greatest browser, you're still going to cut out a sizable percentage of your user base that isn't using the latest and greatest, and they won't be able to run your code. So a solution to this is something called Babel, which is a JavaScript compiler. It takes your ES6 features, such as here we have an ES6 arrow function, and compiles them to the equivalent ES5 version. So you're writing ES6, and they let's call it transpiling. You're transpiling it to ES5 code, so that way it can work on browsers that are fairly old. Additional tool that we'll be using is something called Webpack. Webpack is going to do a couple different things for us. For one, it's going to run your code through Babel, so Webpack and Babel work together. It's going to run your code through Babel. Babel is going to be what turns your JSX into JavaScript for one, and for two, it's going to turn your ES6 features into equivalent ES5 features. One more thing. Typically when writing JavaScript, the only dependency management you have is script tags. And if you wanted your scripts to run in a certain order, let's say that script B uses script A. Inside your HTML file, you actually have to go script A, script B, and get those in the proper order. And you'd have to resort to dirty tricks such as using immediately invoked function expressions, because by default there is no file scope in JavaScript, in order to make sure you don't get bleed through between your different scripts. So it's going to seem unrelated at first, but if you've heard of Node.js, Node.js has had a lot of impact on front-end development. And the way that it's done that is Node.js introduced a new type of scope called module scope, where every file or module also has its own scope, and then you explicitly export things out of those to be consumed by other files. Webpack is a tool that not only allows us to break our code up into different modules and consume them sort of like we would in Node, but it's also going to run, as mentioned earlier, these transformations. So while this tool set is great and very powerful, it can be a little confusing and there's a lot of moving pieces to try to learn at the same time you're trying to learn React. So before going into the React particulars, let's take a look at the toolchain setup, examine the different pieces, and see how we can optimize it for both development and for production deployments. So in case you haven't heard of Node.js, Node.js is a wrapper around the V8 JavaScript engine provided by Google Chrome that allows you to run JavaScript outside the browser. In addition to this, it provides a bunch of other file and I/O functionality and fleshes out the standard JavaScript library a little bit further. One other part it did, though, is as mentioned in the first video, introduced a module system called CommonJS. And additionally, it brought in a dependency manager and task runner called NPM. Now, even though we're not going to be writing any Node.js code, per se, we will be using Node.js to build, compile, and run tasks for our front-end React applications, and additionally to manage dependencies for it. So if you don't have Node, you can go to the official site and grab the latest version, go through and run the installer. Additionally, if you're on OS X, you can get it through Brew. As part of installing Node, you're going to get a JavaScript REPL. And you're also going to get a tool called NPM, which stands for Node Package Manager. Now, traditionally, we manage all of our JavaScript dependencies through script tags. And if we had to use any libraries, let's say we were in a basic project, we would have to create a directory called vendor. Then inside of vendor, we would download a copy of all of our different dependencies, jQuery.js, touch handlebars, and all of our different dependencies, or we'd use a CDN. But either way, inside of our actual HTML file, like so, where we want to use these dependencies, we would have to go script, source, vendor handlebars, and do the same thing for each and every one of our dependencies. And if our app involved multiple pages that needed these, it was a real pain. And we had to make sure to put R's after all of them since they depended on it. R.js file, which we don't have, but if we were to have one, right, and just not very maintainable. Not nearly as good as dependency management systems for most backend server-oriented languages, right? So what we'll do instead is we're going to use Node-style packaging, and then we're going to use Webpack to bundle this up. And what this looks like is instead of script tags, like we had before here, we're going to create a file called package.json, and we're not going to create it directly. We're going to create it through npm init, which is kind of like a git init. It's going to ask you different questions about your project. Most of them are fairly optional. If you're ever going to deploy this or do major things with it, you should fill it out properly. And the end result is going to be this package.json file, which is going to maintain a list of all of our dependencies. So instead of doing script source equals some CDN React, instead we're going to install it through npm by saying npm install save React. And then if we look inside of these node modules, we'll not only see React.js, but we'll also see React's dependencies. And additionally, it updated our package.json to contain React as a dependency. If you're working through Git or a similar version control system, typically you will turn in package.json to your Git repository, but not the node modules. The reason for this is twofold. One, node modules is derived information that we can figure out from the package.json. Two is while most node modules are just raw node JavaScript code, some of them have native components that need to be compiled. So if I were to commit a Node modules that had stuff that was compiled on my OS X system, and you were trying to run it on a Linux system, you might run into problems. So the proper way to do things in most cases, there are exceptions, is to only commit package.json and to add node modules to your git ignore. The other thing that package.json could do for us is run tasks. So inside here, there's this little script section. We can add scripts here. It's kind of sort of like make, where we can define tasks such as build, go. Then if we go npm run build, it's going to run whatever bash command we specified there. So typically, instead of a trivial echo statement, that's going to poke Webpack to build our application, depending on how we execute it, either for development optimized setup or production optimized setup. So in this new system, there's a couple different ways you can manage your code. With raw node, we can use common.js, which looks like this. If we have script1.js, and we have scripts2.js, we can write a function inside of script1, and then inside of script2, now if this was vanilla JavaScript and we were to run this through a browser as a script tag, it would do stuff in the global context, and then script2 would have access to it. And in order to prevent that in the browser, we'd have to wrap this up in Iffy or something equivalent, like so. But you don't have to do that in Node. And furthermore, when you bundle up your package through Webpack, you don't have to do that either. You can kind of think as if Webpack is doing all of the Iffies for you. That being said, if everything was always automatically in Iffy, you would need some sort of way to get things out of here. The way you do that with common.js is through module.exports. So here, if we wanted to export do stuff, we can say module.exports equals do stuff. Then inside a file that's interested in interacting with do stuff, we can say var do stuff is equal to require script1 and invoked. Then when we bring in do stuff into script2, we can run it like so. In addition to managing our own dependencies this way, we're also going to manage our installed dependencies that way too. The difference being, instead of providing a local path here, we're just going to refer to it by name. So we can say var react equals require react. Notice the node dot there. That means we're going to check that little node modules directory. Take a look at the dependency. And see, here's all a bunch of different stuff from React. And we ran this through Node because, as we're going to explore a little bit later, React actually has two different packages now. It has React and React DOM. React is code that is shared between both React and React Native. And the implication of this is that it allows us to do server-side rendering with React. You know, we can still create React components on Node on the server and then render them later with React DOM. We're not going to be doing that in this course per se, but it's something that can be done. And while I currently just showed you common JS syntax, we're going to be using ES6 module syntax, which is compatible. It will compile down to common JS as part of our Webpack process. But one more feature that we have in ES6 modules, as well in common JS modules, is instead of a named export with one thing like this, we could export multiple things by name, like this. Another function. Then this time I'm going to say exports.dostuff is equal to dostuff. Not module.exports equals, but exports dot. And exports.otherstuff is equal to other stuff. And inside of here, I can say var dostuff equals require script1 dot do stuff. That'll just bring one of them, or if we want to bring in the other one, we can say other stuff, like so, and then use it like before. We're not going to be using that syntax while we could. In React, we're going to be using an equivalent ES6 module syntax. It's important to know about some of the details of this because this is what it compiles down to. And what's going on is whenever you do an export, there's one object that is being exported from the file. That object can be given properties like we did over here, right? Where we set one property to do stuff, another to other stuff. And additionally, instead of setting properties on that export object, we could do what we did in the first example, where we reassign that exports object to something else, such as a function or another object entirely. And then we're exporting one new thing, and that's kind of like a default export. It's a little bit more clear in ES6 syntax, so we're not going to dwell on this too much, but do know this is an underlying implementation detail of it. In order to transform our JSX into ES5 and to transform our ES6 into equivalent ES5, we're going to be using a project called Webpack. Webpack is a tool that allows you to use ES6 features in any ES5 compliant browser. What it will do is, here we have, for example, an ES6 arrow function. It will take that and convert it to an equivalent ES5 version without the arrow function. In addition to applying these ES6 transformations, it can also do React transformations, as we'll see over here. And ultimately, we're going to be using this project together with Webpack, so that way we can get both project bundling and these transformations. But let's see how we can use Babel independently. Start with, if we have a blank project, we're going to say npm init and go through and create a new project, because we're going to be installing the Babel tool through npm. And again, even though this is going to be a front-end project, not a Node project, we are going to be running Babel with Node to transform this code. So Node is kind of a development dependency for our project, even though in production we won't be using Node. So go through, you want to populate this with actual information for your real projects, but this will be sufficient for ours. And we'll see we have a package.json here. Usually I would go ahead and do a git init at this point and add that to my Git repo. Next, we're going to install Babel CLI. Like so. And notice we did save dev instead of save. The difference between the two is a little bit more semantics. You know, for dependencies that we only need for development purposes, we'll often do save dev instead. And this should finish in just a moment here. Sometimes Node has to build it if there are compiled components. All done. And again, this whole compiled components aspect up here is why you typically want to avoid checking in the compiled Node modules to your source repository. And see in here, have all the different dependencies for Babel, as long as Babel itself. And additionally, in our package.json, it now includes Babel CLI. So as Babel can apply multiple different transformations to your projects, we have to explicitly say which transformations we want to enable. So we have to opt into React transformations as well as ES 2015/ES6 transformations. Now, if you used an older version of Babel, this might seem different, because in prior versions of Babel, prior to Babel 6, I believe it was, they enabled some of these transformations by default. But currently, in the latest version of Babel, at the time of this recording, there are no default transformations, so you must opt into all of them. So what we're also going to do is we're going to install those transformations. And the command for that is going to be npm install Babel preset ES 2015. Later on for our React project, we'll also be installing a React preset. So go ahead and enter that in. Should install in just a moment. And we'll see that, once again, our package.json has been updated. Another change from Babel 5 was people used to run the Babel CLI as a global command line hook. You can still do that if you installed it through npm install g, but this can create issues because, for one, your environment has an implicit dependency, and secondly, if you have different projects that use different versions of Babel, which can often happen, it's better to not have these global versions of Babel floating around your system. So what we're going to do is we're going to go into Node Modules, Babel CLI, bin Babel, and we can invoke Babel from there. But since that's a little bit, hairy of a command right here, we're instead going to alias this with npm task. So going into package.json, we're going to add a new script called build. And another benefit through doing it here is that whenever you run any npm command, so when we say npm run build, anything right over here is going to look not only your usual system path, but temporarily speaking, it's going to add node modules to that system path so that we don't have to type out the full node modules bin, so on and so forth. We can just say Babel CLI. So what we're going to do is we're going to say Babel to invoke the Babel command. We're going to point it at which file we want. Here we'll just say script.js. We're going to output it to a directory called dist, short for distribution. You can name it whatever you like. Save it. And when we run it, initially it's going to say script.js doesn't exist, but notice it is successfully invoking the Babel command. So let's go ahead and both create that distribution and create a script.js. So a fairly basic ES6 feature is the let variable for block scoping. And what I mean by that is, unlike most languages, JavaScript does not give you scoping for blocks. It only gives you scoping for functions. So if we do something like if true, var x is equal to 4, console.log x. In most languages, x would be out of scope after the block is over. But in JavaScript, x will still be in scope after that block, and we'll be able to successfully print out 4. Now, the new ES6 let feature, so if we declare this variable with let, that will give us block scoping. So after this is done, x will be out of scope. For example, if I run this with Node that has ES6 enabled, notice we're going to get x is not defined. So this works great with Node because it has ES6 and it'll work fine with an ES6 browser, but let's compile this to ES5 so that way our clients with older browsers can still use it. Let's run npm run build again, and we'll see this time that it did successfully build from script into distribution script.js, but the problem is going to be we haven't actually enabled any of those transformations even though we've installed them. So it ran through, it successfully built, so to speak, but it didn't actually change any of the underlying code. The simplest way to bring in these transformations is 1, install a preset, and secondly, we have to read from a Babel RC file, which will specify which presets we want to use. I'm just going to cat this string out to .babelrc, verifying we do have the Babel RC file here, and the contents of it are presets ES 2015. So this is a configuration object saying that, or just configuration JSON specifically, saying that the presets we want to use just ES 2015. Later on, we'll be doing React for JSX. You can apply a more sophisticated configuration in here as well. But pretty soon we're going to be moving on to Webpack, so we won't dwell too much on the details of this, but know they are there. Now, when we run npm run build again and look at distribution, we're going to see that it added use strict up here. And notice it changed my let to a var. And furthermore, it renamed it to _x instead of x. So that way it's unavailable down here. Now that might seem kind of gimmicky and be like, well, yeah, that would work. But what if I would have named my variable _x? Like so. Building again. And we'll see that it gave one _x2 and left the other one as _x. You can keep going through this and playing with seeing how these ES6 features get compiled to ES5. But my point being, this is a very robust production-ready tool. Likely you won't be able to trick it. While it can be kind of interesting to apply these see how these transformations are applied, day in, day out, it's not going to be extremely relevant. You can just write your ES6 code and let Babel take care of the rest. Next, we'll be seeing how to use Webpack. And then after that, how we're going to integrate Webpack and Babel together for our React projects. So, since we won't be managing things with script tags exclusively anymore, let's see how we will be doing this in the context of a web project. Well, if we look inside some boilerplate here for a React application and open up this index.jsx file, for now, don't worry about the JSX part and don't worry about the React part either. That's just incidental. We're purely talking about the import system and how Webpack's going to bundle this up. So all of these imports up here, these can be converted to equivalent common JS versions. For example, import React from React would look something like var React equals require React, and import render from React DOM will look like var render equals require React DOM dot render. We can even get rid of some of this React code. What's important to specify though is our Webpack bundle is going to look at one location that is the root of our application. And from there, whatever dependencies that application brings in, be it third-party dependencies or your own dependencies, So for example, here we had React dependencies brought in. If we also had our own, say, touch rlib.js and brought that in, lib equals require rlib.js. By the way, whenever the file ends in JS, we can exclude the .js part of the extension. And let's say in rlib, we brought in, also this have to export something for. Here I export a number. The module system in React and JavaScript as a whole is very flexible. You can export whatever you want. You aren't restricted to, say, Java, where everything must be a class. You can export modules, numbers, functions, you name it. And let's say this brought in var other lib equals require other lib.js. We had other lib.js module.exports equals test. And what's going to happen is we're going to point Webpack through an npm task. While we could invoke Webpack directly, typically it's done through npm or gulp or grunt. These days, just raw npm tasks are becoming more popular. And what it's going to do is it's going to build a dependency graph for our application. So it's going to go in here. It's going to say, we need this one, and this one. And then it's going to go into each of those files and bring the files that they require and so on and so forth. And it's going to concatenate and bundle them all together into one giant JavaScript file. So we have our code written as different JavaScript files, but in production, when we actually run this, it's going to be one file, typically called bundle.js, that contains all of this. So what we will do is in our HTML file, instead of going script source equals library 1, script source equals library 2, script source equals our app, we're just going to have one. Script source equals bundle.js. That's going to be one giant JS file that contains all of our different JavaScript bundled together. An additional benefit of doing it this way is it's going to, in many cases, enhance performance because clients will only have to download one JavaScript file. You don't really need to spend too much time mucking around inside the bundle.js file. But if you're curious, you can pick it up and see it's all vanilla JavaScript, ES5, all JSX will be gone. And in here, it contains Reacts, as well as our application code and all dependencies. And with this is going to free us up from having to worry about getting our script tags in the proper order. And it's a much more sane, modern dependency management system, and will also create a very simple deployment mechanism. So now that we understand the basic concepts behind Webpack, let's take a look at the configuration file and how we can set this up from scratch. To start off with, we're still going to need to install save dev Webpack. So go ahead and run that command. We're also going to need Babel, but this time instead of Babel CLI, which we used through that command line interface, even if it was indirectly through package.json, it was still a command line interface. Instead, we're going to do Babel loader, which Webpack works with the concept of loaders and plugins. Babel loader is a Webpack consumable version of Babel. So we're going to do Babel loader so Webpack can use it instead of Babel CLI. You're also still going to need to install the presets. The good news is there's no Webpack specific version of those presets. The normal presets will work just fine. So Babel preset ES 2016 and install React as well. And if this were our full-on project, we'd also probably want to install React and React DOM as well. So once you get all those installed, open up your package.json. And this time, instead of our build command being poking at Babel directly, it's going to run Webpack. Even though Webpack isn't on your path right now, Webpack is inside of this node modules. And when you run npm tasks through npm, it puts that on your path. Additionally, in order for Webpack to do its thing, we're going to have this file called webpack.config.js. Many of these Webpack configuration options you can put as command line flags back inside the package.json. It's a little bit a matter of taste, whether you include those here or in a Webpack config. Most people choose to put them inside a Webpack config. Also notice that the Webpack config is a .js file. So you can use full-on JavaScript to configure your Webpack. It's not JSON, it's not a certain configuration language, it is actual JavaScript. And additionally, you can still use .babelrc for your Babel parts, but you can also just put that as a section of your Webpack config, which we're going to see in a moment. So this is just regular old node code. Notice we're using the require that we looked at from our peek at CommonJS. One other note is, since this is Node running on the Node command and not browser stuff, we're going to use Node's native CommonJS and not use any sort of ES6 module syntax, because and currently when writing Node, it's still proper to use CommonJS syntax and not ES6 module syntax like it is with React. All right, we're going to say var webpack equals require webpack. That's going to bring the webpack dependency. We're also going to bring in path, which is just a Node standard library utility for working with paths. And kind of a best practice, we're going to create these constants up here to specify our build directory and our app directory. Our app directory is where we're going to read in our code from, and it's in dir name, which is just a little alias to our current directory. The reason we're using dir name instead of relative path is because dir name will point to the directory that this file is in, not to your actual current directory. So no matter where we run these commands from, it will look at the proper spot. App is where we're going to write our code, and build is where we're going to build it to. Build is kind of just like the directory we used before, just a little bit different name. It doesn't really matter which one you use, just make sure they line up there. Apps containing a bunch of different files in here. And build is where we're going to write our bundle.js to. So then what we're going to expect is we're going to have this configuration object, which is kind of like our Babel RC JSON. And then we're just going to export that as a top level export from this file so Webpack can consume it. We need to specify the entry point, which is the root. Now the entry point has to be a singular file, because every application will have one file from which that file you can build the entire app's dependency graph. So we're going to go ahead and point at there. Then we're going to specify an output. The path for it is we want to put it in the build dir. We don't want to just dump in the current directory. Call it bundle.js. You can call it whatever you want. And this little public path thing here isn't so relevant right now, but later on, when we serve this through Webpack dev server, that public path is going to be where this Webpack dev server serves it up from. So that way it's not under, /build/ we just get it on / from our local host. This is just specifying where our entry and outputs are. Here's where we're going to specify our transformations. So we have a loader section right here. Currently we only have the Babel loader, so that's why there's just one object in here. If you desire, you can bring in other loaders as well. And the first part for this loader is we're going to say that the loader type is Babel. It's going to include everything in our app dir, which if you recall is right up here, that little /app right here. And then there's this little test part. So what test is doing is it's not saying that, oh, we're going to run tests here. It's some sort of test that it's going to run against the file names to determine if they should be included. Because if you run tests like this, it's going to selectively choose them. So we're saying here, we put a little regex that's saying any file that ends with JS and then optionally an X, the little question mark thing is a regex pattern, saying that it can include the X or it cannot include the X. Either way is fine, but it must have JS beforehand. So we want all of our .js and our .jsx files. And then this little query presets thing right here, this is just inlining our Babel RC configuration into our Webpack file. So that way we don't have to maintain two separate files. Some people like to have a Webpack config and a Babel RC. It's a little bit matter of taste. I just went ahead and put it in here. Then what we're going to do is, like in the last section, npm run build. Webpack's going to be invoked. Again, Webpack is loading Babel. Babel is applying the ES6 transformations and the React transformations. And Webpack is what's bundling all of our different JavaScripts into one concatenated file. Then take a look in builds. And we have the nice little bundle.js file right here. So this current setup is okay. It can work for development or production. But there's our little tweaks we can make to make it better for both development and for production. Something that can be desirable for development is, hot reloading, page refreshes, syncing it so that as we change files, it will automatically update the bundle. And something we can want for production is minification and things such as that. So we're going to look next in how to tweak this a little bit into setups that are more optimized for a particular use case, be that development or production. Let's look at how to take the Webpack process that we created in the last section and make it a little bit more development friendly. And by development friendly, I mean things like when we change a file, that change will automatically be pushed to our live view of it. So in order to do this, we're going to install another tool called Webpack Dev Server. And what Webpack Dev Server is, it's a little tiny node server that will serve up your bundle.js and your index.html. It also will have watchers. such that whenever you change those files, it will rebuild the bundle. And furthermore, it sets up WebSockets, where if you're not familiar with WebSockets, they're technology that enable basically real-time instant communication between a server and a client, such that when our server detects a change in a file, it's going to, through the WebSocket, push those changes real time to the browser, so you don't even have to refresh your browser page. So another difference is when we run it through Webpack Dev Server, instead of the command being Webpack, we're going to have the command be Webpack Dev Server. And while we still could call it build, dev is probably a better name. So we're going to say npm run dev. So let's look at how we're going to change our Webpack config for this. All the stuff from before is still basically going to apply. We're still going to bring in Webpack. We're still going to bring in path. We're still going to specify a builder and an appter. Other config parts are still going to be there, but the new parts are going to be this dev server section and this dev tool section. So dev server, let's look at that first. Inline true, without this being there, it'll run your code inside of a web frame. I don't really like it doing that. I think it's a little bit better with the inline view, so I just went ahead and specified that as true. Content base is where it's going to serve it up from, because recall that it's not only serving up your bundle.js, but other related files like your index.html. We're going to serve it from the builder. We're also going to specify a port that we're going to run the server on. And then DevTool source map will turn on source maps, which if you haven't used them before, source maps are an interesting tool so that we can, inside our sources view of our web debugger, we can still see the original uncompiled version of the code. So what we're going to do now is we're going to say npm run dev. It'll build the project and it'll host it up from, as we specified here, localhost 333. And if we go visit there in our browser, we'll see that we have the code being served up. And I'm going to leave this running and open up another tab. And if I navigate back into our projects over here, so I'm going to leave this running. And we'll see that if I go into app, open this up, again, we don't really know React just yet, but currently we have one exclamation mark right here. I'm going to go through and I'm going to add a couple more, save the file. Notice that this is loading because Webpack recompiled our bundle, made some changes to it. And furthermore, I did not refresh the page. Without me doing a refresh, this updated right over here and add the extra stuff. And this is very handy because when you are writing React, you don't have to be regularly going in here and rebundling over and over and over again. That can get pretty old pretty fast. And additionally, it's nice having those changes automatically pushed through to the browser. One other thing to note about this setup is that if we look inside of the build directory, we'll see that there's only an index.html and there is no actual bundle.js. So you might see that and wonder, hey, is this not working okay? Well, it is, because what's happening is when run through dev server, it doesn't actually write the file to disk. It keeps the bundle.js in memory and updates it through there without writing it to disk. As we're not going to be deploying this and we're going to be remaking it, there is no point writing bundle.js to disk, so it made more sense to keep it in memory when running with Webpack Dev Server. Next up, let's take a look at a production optimized setup for Webpack. What we've been doing so far is useful for production work, but when running in production, we're going to want to create that bundle.js and not have it in memory. And additionally, we're going to want to run it through Uglify so it's minimized. So opening up the old version we had before, right here, and opening up this production-based version, let's discuss what's changed. So in production, we don't really need a dev server, nor do we need source maps in. So we went ahead and we got rid of those entries in here. Notice how it's just outputs, then module, where before we had this dev tool and dev server setup. Another change that we're going to make is that in addition to loaders, Webpack has something called plugins. Now, it can be a little bit confusing to beginners what the exact difference between plugins and loaders is. In a nutshell, loaders work on individual files. So anything we specify as a loader, it's going to go through each and every one of those files and apply those transformations on a file-by-file level, where plugins work on the entire bundle. So each file is going to run through your loaders, and then the Webpack bundle as a whole is going to run through your plugin. So this plugin, one of the built-in ones, there's many others, is Uglify, which will minimize our code. We set a new plugin section, new Webpack optimized Uglify.js, minimize true. Notice that we didn't have to specify any tests like we did here, or include, because again, plugins do not work on the file by file level. They operate on the bundle as a whole. And one other change we made is in our package.json. Instead of it being deb webpack dev server, we've changed the command to build, and we've changed the command back to just regular old webpack. So now when I run npm run build, like so, will take a little bit longer than it does with our dev setup because it's doing a little bit more operations in terms of the minimization, but the end result will be worth it. Okay. And then we're going to go into build, and notice how this time there is a bundle.js, unlike the in-memory dev server. And opening up, we're going to see that this file is actually only 21 lines because it has been minifized through the Uglify plugin. And something like this, you can go further in depth into minimizing and optimizing your production bundle. You can do things like code splitting and lots of other great features. But for the purpose of this tutorial, this will be sufficient, and you're off to a great start with a production build.
Well, it's great to understand the basics for how Webpack and Babel work together to bundle up your application. In truth, going through and creating these configuration files from scratch and maintaining themselves can be kind of a chore. As such, one of the most popular tools that's come out is called createreactapp. It is a CLI interface to automatically bootstrap React applications. And let's begin. So the way you can install it, if you don't have already, is through npm. Do npm install g create React app. After running this command, it will give you a global command called createreactapp. From here, you can type in an app name, such as my app. It's going to run through and bootstrap an application for you. And while it's doing that, let me show you the GitHub page for it. It's on Facebook Indicator, Create React App. And there's quite a few different things it can get you. And the idea behind this is that for the most basic common use cases with React, you can just get up and running with ES6 compilation and Babel. It also gives you a couple of other nice built-in features, like a public folder, a little bit more of a same directory structure. It'll give you some linting. It'll give you some global variable capabilities. You can set up a server proxy. You can run tests. And finally, and the thing that I find the most useful about this is it gets async await and all those great Babel features in for you. Additionally, if and when you decide you outgrow Create React App, it's easy to eject out of it and make it your own. Okay, now that it's all ready, let's CD into the app. And one other quick note is you'll see that it describes these commands in terms of Yarn and not NPM. Yarn is basically an alternative version of NPM maintained by Facebook. Feel free to use it as well, or instead, but you do not have to. NPM will work just as well. Okay, seeding into there. And initially, we'll see that when we open up package.json, the only dependencies we have in here are React, React DOM, and React scripts. We are still, in fact, bringing in Webpack and Babel and all that other good stuff. It's just hidden behind this React script dependencies for us. Another nice feature is that you can keep that original Create React App command line tool, and as new versions of Babel and Webpack and all that come along, it will update it under the scenes for you. We're not going to show it inside of this video. It's a little bit beyond scope, but you can also point to alternate versions of React scripts. There's some community maintained ones if you want to have some other features instead of the defaults. And right here, we'll see that we have a start command. What the start command is useful for is a Webpack build that's optimized for developments. Here's one for build, where this will be a production optimized build. Here's one to run some basic testing, and then here's how you can eject into a custom Create React App environment. Okay. So for starters, we'll just go ahead and run npm start. And once that gets kicked off, it will be running on default of port 3000. It'll even open you up to the browser, just like that. And I really want to emphasize how much of a huge win this is. Back when I first started writing React, I recall having to spend literally 2-3 days just trying to get something to build and show up. But now you can jump into here, you can run create React app, and you can get going right away. Okay, looking into here, some other stuff we have. Public, you can just drop things in here for static serving, as we mentioned earlier. Here's a little one index.html file that React will inject all of your app into. Has some reasonable standards with the viewport and the meta tags. It will inject your app right into there. Going into source, we see this is the initial structure it gives you. Another nice one of React app, create React app, is that it gives you service worker support right out of the box that you do not even have to configure. You can opt out if you like, but I think it's a useful thing to have in there for some progressive web apps. Okay, the entry point of all this is the index.js file. Just go ahead and loads React, React DOM. It brings in the initial CSS. React Create React App gives you some CSS support out of the box. Over in a later section, we'll be taking a little bit more of an in-depth look at the CSS part of the picture. Okay. Brings in the app, brings in the service worker, renders the app into that root element, and kicks off the service worker. Then if we go into the app component itself, we have a pretty basic class-based React component. We also see that it includes some basic styling, right, which it imports and runs through Webpack right there. Give us these styles. An additional nice detail of Create React App is if we come over here and we open up the developer tab and go into sources, we see that source maps are all set up for us, which is really great because trying to debug compiled Webpack code can be a bit of a nightmare. So that's kind of nice to have worked in there. Then notice this little note about this build not being optimized. Well, just like how in the last section, we showed how we can use Webpack to do things like minify and all sorts of other goodies for deployment. Create React App can do that for you as well. So if instead of start, if you do npm run builds inside of here, it's going to do the same thing, but instead of a development style build, it'll give you an optimized production builds. And so far, everything's been in memory under the hood through a Webpack dev server. That's why we haven't really seen any files being created here, but this will actually give you a static build, which you can deploy. And it builds all of that into this build folder, where if we cd into that, we see that we have the index.html. And then inside of static, we have all of our JSS and CSS. Here's the compile down bundle. All one line and good to go. And then the last thing is, let's say that you want to do something that isn't supported by Create React App. Let's say that you have different opinions about production optimized builds, or maybe you want to opt into CSS modules or use some other sort of Webpack plugin. What you can do there is you can type in npm run eject. You can do this at any time, but it's a one-way operation. You cannot uneject from an injected app. And when we do this, we see that we can open up the package.json. And all of the magic went away. Now we have all the underlying dependencies that were hiding behind that React scripts plugin. Right? We also see that fetch is brought in here too, Webpack, test, promise. And our start commands have changed a little bit, but not much. And all of that Webpack configuration is hidden inside this config folder right here. And from here, you can go into it and you can say, well, let's say I want to edit my config for dev. I'd open up this file right here. And something that's kind of nice is they went through and they annotated everything pretty extensively. So I would also say that createreactapp ejecting can be a good way to learn a little bit more about Webpack if you're curious about it. It's a pretty good file they did here. Everything is nice and annotated. Okay. Then if you wanted to change production, you do the same thing, but in the .prod file. One final bit is while we're going to be doing testing more in part 2 of this video, just showing you what it has, you can run tests through createreactapp. If I do npm test, it does some pretty basic jest-based testing. And the file for that is these little .test files. And we see here, this one just says simply, it renders without crashing, it creates a div, and then renders it. While there's more to experiment with, that covers really the fundamentals of what you need to get running with createreactapp.
So even though many people have been doing JavaScript in some shape, way, or form for a long time, not many people actually know the JavaScript language very well. And it's surprising the number of frameworks and libraries you can use very successfully without really having an in-depth understanding of JavaScript as a language. For better or worse, React is not one of these libraries. In order to use React to its fullest potential, you need to have a fairly in-depth understanding of JavaScript as a language. So if you already have an in-depth understanding of JavaScript as a language, feel free to skip over this section, but for those of you that are feeling a little bit unconfident in your JavaScript abilities, definitely check it out. And this isn't going to be a full in-depth or full intro to JavaScript by any means, but it's going to be a curated selection of some of the advanced JavaScript topics that frequently pop up in React. One of the most common advanced JavaScript techniques that pops up a lot in React is functional programming. So let's take a look at that first. So let's say that you have an array of numbers, like so. A common pattern is to iterate over all these numbers and doing something with them, such as printing them out. We can do this with an old school C-style for loop. Verifying. Great. Another common pattern is to, from an array of numbers, generate a new array of numbers with something that's a little bit different about each one. Say we wanted to multiply each one of these numbers by 2. Then instead of logging out, we would say new numbers at I is equal to the original numbers at I times 2. So there's nothing wrong with doing it this way, but there's a little more powerful way to do it, and a way of doing this that is much more common in React, and that's using functional programming techniques. So some of the issues with doing it this way is that here we're programming through side effects. There is no real return value, so to speak, from here. Even though this for loop isn't returning anything, we are kind of sort of getting a return value. It has a result being this new numbers array. And furthermore, we are doing this immutably. We aren't changing the original array at all. And when looking at for loops, it's hard to tell without really kind of diving into the body about whether you're doing something through mutation or whether you are doing things immutably. And using functional programming techniques is going to add a little bit more semantics to that. It's kind of like if you're a fan of HTML5, how things used to be just divs, but then went from divs to divs and sections and articles and aside. Even though, yes, technically speaking, it's equivalent in power to a div, it gives additional semantics. So the first functional method is for each. To do this equivalent one in a for each style, we would say numbers.forEach number console.log number. So beauty is in the eye of the beholder a little bit, but many people will consider this a more elegant solution. It's a little bit more readable. It reads kind of like English. Numbers and for each number, log number. A little bit later on, when we cover ES6 arrow notation, we're going to see an even more elegant and concise solution to this. And for each, whenever you do that, that's making it clear that there is no return value. For each doesn't return anything useful. So we're going to be just using it for its side effects, which is logging out a number. Or potentially if we were wanting to mutate the original array, one scenario we could say, all right, let's take all these numbers, multiply them by 2, but change the original array. Then for each would be appropriate. Oops, slight bug there. Now we're no longer referring to it by index because we're using this for each loop. Additionally, if we wanted the index, we can include a second argument here for that index and say numbers at I is equal to number times 2. And there we have it. So as we're going to see with React, React encourages an immutable style. We're going to have these different React components that we create. And whenever we want to change them, more often than not, instead of mutating the original component, we're going to throw it away and create a new one. So it's kind of good to get in the habit of this immutable style, even when doing your regular JavaScript. Because what's going to often happen is, well, here we're taking an array of numbers and mutating the original array to contain the numbers times 2. Instead, we could have created a new array and left the original one alone, like we did here. Now, we could do this with for each as well. We could say var new numbers 2 and refer to new numbers 2 inside of here. But there's a better way to do it. And that is by using numbers.map, which unlike for each will have a bona fide return value. And checking out the return value. We have an array with each of the original values multiplied by 2. And furthermore, if we're to print out the original array, we'll see that it has been preserved. So even though this might be fairly intuitive in terms of how it reads, let's look at it a little bit deeper and understand with both of these functional methods exactly how they're operating. So for each of these, whatever the length of the array is, whether it's numbers or whatever, we'll see that this one has a length of 1, 2, 3, 4. Whatever function you put inside either the for each or the map function is going to be invoked once for each element. So if you have an array that's 10 long, that function will be invoked 10 times. If you have an array that's only 2 long, it'll be invoked twice. If you have an array of length n, it'll be invoked n times. What it's going to do is it's going to invoke this function, and as the first argument in both for each and map, it's going to be the respective element in the array. So for example, let's look at this map one. The first time we invoke this inner anonymous function, the value of number will be 1. Next time we invoke it, the value will be 2, then 3, then 4, and so on and so forth for the length of the array. Now, where these start differing is for each isn't going to return anything, but map is going to return a new array. And it's important to note that that output array is always going to be the same size as the input array. So here, where we had numbers of length 4, new numbers 2 is also going to be of length 4. And what it's going to do is whatever we return inside of the anonymous function, that's going to correspond to a particular value in our output array. And we're going to go through and do this in order. So however we modify the first value, whenever we run, say, 1 through there in the 0th index, whatever we return here is going to be in the corresponding 0th index of the output array, and so on and so forth. We're going to populate this output array in order, just like we process the input array in order. So the reason that this is called map is essentially we're mapping inputs to outputs, where originally we had 1, 2, 3, and 4. We now have 2, 4, 6, and 8. And you can kind of imagine it as if it's taking this set of inputs, this set of outputs, and it's giving us a map to get between them. Like so. Each input has a corresponding output, and if the input is at a particular slot, say index number 2, then the output, its respective output, will also be in index number 2. So another thing to take note of in JavaScript is that there's no such thing as function overloading. So just as a little bit of a side note, this anonymous function we supply, we can leave out this second argument or include it. And if we do include it, it's going to populate the index value. We can also do that for map. We can index here. And while possible, it's not as frequently used with map as it is with for each, but it is there if you ever do need the index while creating your output array. So map is the most frequently used one, because usually the paradigm is going to be that we will have, say, so for example, where we're heading with this, we might have an array of objects describing articles. Something like this. And we can't take this and directly render it to any sort of HTML element, you know, saying div injects blog here, right? We want to convert these into an equivalent JSX or React component, and we will do that by mapping each of these vanilla JavaScript objects into a React component. Again, that might not make a whole lot of sense yet if you haven't done any React, as this comes before the React part, but I just want to show you the relevance of this and where it's going. Now, occasionally useful is the filter and reduce methods. While for each iterates through an array and doesn't produce an output value, map iterates through an array, giving you a new array of the same length. Filter will iterate through an array, and it will give you an array that is the same size or smaller. So if you need an array, an output array that doesn't include some of the things as your input array, you can't do that with map. The closest you can get is creating null elements in those missing slots. But if you want a bona fide smaller array, filter is the right tool for it. Again, with a numbers array, let's say we had var numbers equal to 5, 10, 4, 3. And we wanted to create a new array that contains only the even numbers. We could do this with a filter function. Just like for each, it's going to be a method on the array, and it's going to take a callback function that's going to be invoked once for each element in that array. The difference is going to be how we handle the return value from that anonymous function. So in map, whatever we returned would set our corresponding output value, but in filter, we can't actually change these values in the output. So our output array will include or won't include 5, it will include or won't include 10, 4, 3, and so on, but it can't actually contain any elements that weren't in our original input array. All filter does is pluck some of them out, giving us a potentially smaller array. And whatever this function evaluates to will be converted to a true or false, because in JavaScript, it has this notion of not only true and false, but also truthy and falsy. And often you'll return true or false explicitly in here. Ideally you will, but no matter what you return, it will be evaluated true or false. And if this function evaluates to true, that respective input element will be in the output array. And if it evaluates something falsy, it won't be included in the output array. Another way to put that is this function is going to be a predicate function, a function that we want to evaluate to true or false. So we could simply say return number mod 2 equal to 0. This is just a way to test for a value being even. If this expression right here evaluates to true, number will be included in the output array. If it evaluates to false, it will not. So running through this input set, if we then do console.log evens, we'll see that it only has 10 and 4, and it removed the odd elements. Now to get really powerful with this, let's say that we wanted to add 100 to every even element of the array. We could then go take evens and say var results is equal to evens.map function number. Return that number plus 100. So what we have here would work okay. We can still log out .log results and see that we have what's desired. But a way that we can make this a little bit cleaner is instead of returning the result of this filter to an array like we did right here, we could actually chain it with a map call. And what I mean by that is, let's go down here. We're going to say results to, and right here, we're going to call .map. So what's going on is numbers.filter is returning an array, and often when we chain it, we'll start writing it out like this, so it looks a little bit cleaner. There's a couple different ways to lay this out code-wise. Is filter right here is going to return an anonymous array, you could almost say. On that array returned, we're not going to save it to a variable. We're immediately going to call .map on it. We're filtering the array and then immediately mapping the array. Like so. And looking at the end result. Same thing. And even though they're equivalent, this can help cut down on code length and unnecessary temporary variables. Well, here we just had one filter and one map. You could chain these relatively arbitrarily. Although it's not recommended to get too deep, not have too many chains, because the more you chain on there, the harder it can get to debug. So the last functional method is a little bit trickier, and it's called reduce. So while map was interested in taking an input array of n and generating an output array of n, and filter is interested in taking an input array of n and returning an output array that is somewhere between empty and the length of the original array, leaving those original elements alone. Reduce is useful for when you want to take an array and reduce it down to a singular value. For example, going back again to numbers, and all of these examples, even though I've been doing them with the number type, it is applicable to strings and objects and whatever type you wish to do. There is no restriction saying that you can only use functional methods on numbers. You can use them on any type, but do keep in mind that all of these methods are array methods. They don't exist on objects or array-like objects such as arguments and node lists. So if you want to use these methods on them, you're going to have to convert those to an array first or pull them off the array prototype. At any rate, so let's say we had numbers 1 to 10, 15, 100, why not? And we wanted to sum them all together. We wanted to get one final sum, kind of like if we did a for loop. Verify. So the functional way to do the same thing will be to say var sum is equal to numbers dot reduce. And again, reduce is going to take an anonymous function. The signature for that anonymous function is going to be a little bit different. We'll see that in a moment. And it's also going to take a second value. This reduce takes two inputs, first one being a function, second one being a starting value. And then inside of here, we have two parts, the memo and the value. What the memo is going to start off as is whatever value we put right here. So if we put a 10 right here, the very first time we call this anonymous function, this would be 10. Now, whatever we return from this function, the next time we call the function, memo will be whatever we returned from the last time. Now, value, on the other hand, is going to work similar to our for each and our map and our filter. And for each invocation, we should say, of this anonymous function, it's going to assume a value from numbers. So first time through, value will be 1, then it'll be 2, then 10, then 15, then 100. And what we're going to do is we're going to combine memo and value together and return a new value that will be the value of memo in the next invocation. In order to properly exploit this to add everything together, we're going to start this off as 0, and we're going to return memo plus value. Verifying. Okay, same result as before. And what's happening is on the first invocation, memo will be 0, which, by the way, memo is kind of like the abstract general term for this concept. Often this will be named something more domain specific, such as sum or total, where this sum is a different sum shadowing this one over here. The first time this is invoked, let's walk through this for each invocation of the function. Sum is going to be equal to 0. Value is going to be equal to 1. Okay. 0 plus 1 is equal to 1. So the return value of this is going to be 1. And that means on the next invocation of this anonymous function, sum will assume the value of 1. And value will assume the next value in the array of 2. And 1 plus 2 is equal to 3. So next time through, sum will be 3, value will be 10. So we'll have 3 plus 10, which is equal to 13. Next time through, sum will be 13, value will be 15. And we're just going to keep on going through this process, and whatever the final value of sum is, our memo, that's going to be what is returned from this reduce function and assigned to our variable over here. Now, a common gotcha when working with reduce is to do this. It doesn't matter what the value of sum is at the end of the array invocation, because sum is a local variable that will go away at the end. What matters is what we return. So this won't work. What's going to happen is we're just going to get undefined, because every JavaScript function implicitly returns undefined if you don't return anything else. So even though this could look like it'll work, in actuality, we're returning undefined each time and going to get a final value of undefined. Like so. Cool. So again, all these different functional methods, you're going to be using map the most frequently, but the other ones, for each, reduce, and filter, will also be useful on occasion. And even though you could write React code using standard for loops and not map, you're going to find that you'll have a much more enjoyable React experience when using functional methods, and you'll additionally be writing much more modern idiomatic React code that follows the community best practices. So one of the most confusing parts about JavaScript is the this keyword. Even people who have lots of experience in other programming languages will frequently get tripped up by this in JavaScript. In fact, having in-depth experience in another language is almost a liability in certain ways, because the way this works is so different from how it works in other languages. People will often try to treat it as if it worked the same way as it does in other languages that I've experience with, and then they'll be shocked and surprised when they find out that it works completely different. In most languages, this refers to the current object. So if you're inside of a method, say an instance method, this will refer to the object that called that instance method. So frequently in JavaScript, this will refer to the current object, but it's a little bit more complicated than that. It's almost kind of just incidental that it equals that. The ruling behind how it determines to set the value of this has a lot more going on. So to start off with, as many of you probably know, JavaScript does not have classes. It has object-oriented programming, but it is a prototype-based language. And we simulate classes with constructor functions, such as this one, where this is a constructor function for a person. Also take note that the capital P here, it will work the same with the lowercase p. The capital P is merely a convention. And we'll say this.name is equal to name. This.age is equal to age. Then we can also create methods inside the constructor function. Say this.sayName is equal to hello, my name is name. Now, you don't want to define methods inside of constructor functions because even though it'll work correctly, we're going to run into major performance issues with it. The reason being, let's look at how this constructor function actually constructs an object and why this is going to be a performance issue. So if we say var p1 equals new person, like so, then what's going to happen is what's setting this inside of this function call, because really when we say new person, we are still invoking this function up here. We're just invoking it a little bit differently. While this capital P doesn't make this function be treated any differently from a normal function, the new keyword is saying, well, when this new word is here, treat this person function as a constructor function. And when treated as a constructor function, a couple of different things happen. The first one is that we will set the value of this. So the only things that are going to set the value of this are the new keyword, the dot, when we call functions with the dot, bind, call, and apply, and the arrow functions. So inside of here behind the scenes, you can kind of almost think about this as we're saying this is equal to an empty object. We're also going to set up inheritance. Discussing how the inheritance is set up is a little bit beyond the scope of what we're trying to do in this little JavaScript intro. But basically what it's going to do is whenever we refer to P1, it's going to have this little proto property here that contains things on its prototype. We'll get there momentarily. And the last thing it's going to do is usually a function will implicitly return undefined. But when called with the new keyword, this function will implicitly return this. So that means when we call this function right here, what we're doing is inside here, this is a new object. We're going to assign it a name property, an age property, and a say name property, and return that newly created object and assign it to P1. Not exactly because of an inheritance setup, but so far what we've done isn't terribly different from saying with an object literal, but we get the extra inheritance bits. So that's one thing that sets it, is that object literal. So as mentioned earlier, this isn't really the proper way to do things. Really, we would want to say person.prototype.sayName is equal to the function described above. And the reason we do it that way is because before, if we were to create another person, var p2 equals new person, Tim14, as it was going through here, back when we had this dot say name is equal to a function, not only would P1 and P2 have their own copies of the name and age property, which is desirable, but they would also get their own copies of the say name function. So even though those functions would be equivalently implemented, we would have multiple copies of that function in memory, which creating all those extra functions can create performance implications. So what we're going to do instead is we're going to put it on the prototype, which as a super object-oriented language, I should say, functions are also objects. So even though person is a function, it is an object, therefore it has properties. And one of the built-in properties of functions is prototype. Initially, it is set to an empty object. So if we say console.log person.prototype, that's going to give us an empty object. We're going to put new stuff on that prototype because what's going to happen is whenever we look for a property, say p1.sayName, it's first going to check to see if that property exists on the object, which it doesn't. Then the next place it's going to check is the object's prototype, specifically the prototype of the constructor function that created it. So when we look for sayName here, it's not going to find it inside of P1, but it is going to find it on the person prototype right here. Now we're getting into a little bit harder to understand territory with this keyword, because back when this function was up here and we did this dot name right here, we could find this through lexical scoping, right? Because implicitly this was equal to an empty object right here, and inside of that function sayName, when we did this dot name, it can look in the enclosing lexical scope and find it right there. However, in this new prototype-based version, there is no this in the enclosing lexical scope, so it won't find it there. That means JavaScript is using a different rule to determine the value of this. And the ruling that it's used here is called dynamic scope. So most programming languages use lexical scope, which even if you don't really understand that term, you probably have an intuitive sense of it. Where in lexical scoping, if we can't find a variable in the current scope, we check in the enclosing scope beforehand. But this doesn't work that way. This is dynamically scoped and will be set based on which function, based on how this function was called. So in this case, right here with sayName was invoked with the dot operator. There's a dot right here. And that means inside of sayName, whatever is to the left of the dot, in this case P1, inside the function is going to be the value of this. So when we did P1.sayName here, this is equal to P1, and everything works out okay. And similar, when we do P2.sayName, in this case for sayName, when we invoke it right here, inside of it, this is going to refer to P2. This allows different objects, or different instances, so to speak, to share the sayName function. Now, so far, this is all pretty useful, but where this starts getting confusing, and we're going to see this pop up in React a lot, is as functions are first-class values, meaning they can be used in any context, just like a string or a number can be assigned to a variable, returned from a function, and used as an input to a function. Same thing with functions. So no matter what your programming background is, if I were to say var name is equal to p1.name and log that out, that probably wouldn't confuse you at all. That seems pretty intuitive, where it is just, getting a reference to p1.name and assign it to here. But what might seem a little bit stranger depending on your background is saying sayName is equal to p1.sayName. So we're referring to the function directly here. We're actually pointing at the function itself. There are no parentheses, so we aren't actually invoking this function. We're referring to the function directly and assigning sayName not to the result of p1.sayName, but to p1.sayName itself. Which if we were to log that out, it's going to give us a little string representation of that function. All right, so that's interesting. So what's going to happen is we're going to have React components that are going to instantiate components inside of that component. And often that inner component is going to want to call a method on the outer component. And the way that we do that, as we'll see later on in the series, is instead of passing a reference of the outer component down to the inner component and then calling the method off that reference, we're actually going to pluck off the method like we did here. So we're going to take an instance method off of the parent component and pass that method as a standalone function down to the child components. Where that gets messy and incorrect is now when we call sayName, and I'm going to turn on strict mode. I'll say why I'm doing that in a moment. We're going to get, hello, my name is, cannot read property name of undefined. So what's going to happen with strict mode on is it's going to set this to undefined if we don't set it to something else. Now, that's more useful than the default behavior of this referring to some sort of global, which will cause our code to silently not do what we want. So what's happening is when we called sayName right here, there is no dot, meaning there's nothing to the left of the dot, and there is also no new keyword, meaning we didn't do anything to set the value of this here. And we're in strict mode, meaning this is going to be undefined. So in effect, we're trying to do undefined.name. Now, this is going to be an issue because, as I said, this is more frequent how we'll pass things down in the React component. And in the next section, we're going to explore a variety of fixes for this issue. In the last section, we saw how there are some implications with this, where when we remove methods from the object that were created, this will no longer be set properly. As that's an issue that's going to pop up very regularly, very early in React, we have to know tools to resolve it. And we're going to fix that problem with the special methods bind, call, and apply. So popping up similar to what we had last time with this.name is equal to name, this.age is equal to age, and on the prototype, we're going to say sayName function. Okay, like so. So we're in the scenario when we did P1 is equal to new person, and we said P1.sayName. That will work as expected. What do I do there? Oh, whoops, got to pass in a name. Okay. And then we run to the issue where we can pull that off, like before, turn on strict mode. And when invoked, it's going to grind our code to a halt. So the way that we can fix this is by explicitly setting the value of this inside of here. So again, functions are objects. They have properties. We already discussed how prototype is one of them. Every function has bind, call, and apply. And what they will do is they will set the value of this inside of the function for us. So I always like to have less concepts to worry about and build up from, take a small set of concepts and kind of derive the others from there. So to make our lives a little bit easier, for now, we're just going to say call and apply are the same. I'll cover the very slight difference between them momentarily. And we're just going to focus on bind and call. So bind and call both work on setting this, but one does it through a hard binding, so to speak, and the other one through a soft binding. So let's look at call first. So what call will do, if we do sayname.call, this is still going to invoke the sayname function. So it's still going to run this code right here, even though we did it with .call instead of, like we had before. But what's going to happen is whatever we put inside of these parentheses is going to be the value of this inside of there. So in here, if I were to pass in P1, now when we look at this function, even though there's nothing to the left of the dot setting the value of this, call is setting the value of this, so we'll get Joe like we did before. Furthermore, if we were to create another person, see, well here I pulled sayname off of the P1 objects, they're right here, but it will also work with other person objects, like here. Or frankly, it'll even work with other person-like objects, meaning anything with a name property. This is one of the most flexible parts of JavaScript. Okay, so this is one way we can fix it. And something else to point out is currently we have this function that didn't take any arguments. Let's say that kind of contrived, but in addition, this function took in some argument and then would just say console.log, whatever that was afterwards. If we want to use that with call, so the first argument is going to set the value of this, and all subsequent arguments are just going to be passed into the underlying function. So here, the second argument is going to get passed in right here. The point I'm trying to bring across is even if your function takes arguments, you can still use it with bind and call. We've discussed how call works, and apply works basically the same way. So before, when we had sayname is equal to p1 dot sayname, and we would pass in all arguments like so, sayname.call this hello. When we do it with apply, instead of supplying additional arguments as comma separated ones, like so, we're going to bundle them up inside of one array. Or in this case, like that. Oopsies, passed the wrong value here. Like so. So conceptually, they really behave the same, but they have a slightly different PI. One expects comma separated, one expects an array. And the way I kind of keep it straight is the C in call is for commas, because it expects a comma separated one. And the A in apply is for array, because it expects an array in its API. So both call and apply will only set the value of this for one invocation. So we'll see here that if I go back and do sayname again, without the call, it'll work just like it did before, i.e. it won't work at all and it will break. Now, if we say bind instead, what's actually going to happen is instead of calling sayname with this particular value of this, it's actually going to create a new function entirely. It's going to create a bound version of that function that we can use over and over. So I can say var bound sayname. And now for the lifetime of this function, whenever I invoke it, it will have this value hard-coded to P1. This can be useful, especially in React, because what we're going to be doing is in those parent components, if we want to pass a method down to a child component, we will bind it before passing it down. So that way, when the child component calls that method, it will refer to the proper this. In idiomatic React code, developers will frequently make use of ES6 features. So in order to make the best use of React and be writing fully modern compliant idiomatic React, we're going to be taking a quick look at some of the different ES6 features that are commonly used in React projects. And the first one of these is pretty quick and easy. It's called template strings. So in many JavaScript projects, you've probably seen people when they have a variable and they want to print it out, they'll concatenate it together with another string, say, while this gets the job done, it's not very elegant. And when you're doing very complex strings with lots of variables, it can get a little bit messy, particularly with URLs. So ES6 introduced something called template strings, where we can inline the variable into the string. And in order to utilize this, template strings must start with a backtick. So not a single quote, not a double quote, but a backtick, and people often get confused about that symbol. It's right by your escape key on most keyboards, sharing keys with the tilde symbol. So template strings will begin and end with a tilde, and you can do them just like normal. So we can have one like that with no sort of variables, and it will work like a usual string. But inside of there, we can put little expressions that have a $sign and curlies. Between those curlies, we can evaluate expressions, and whatever they evaluate to, we put inline into the string. So a very simple expression would just be a variable name, which will evaluate to Tim, and we'll get the same result as before. We can do more complex things inside these template strings. Like, for example, we can do math. And even more complex things like call a function. So while template strings are a relatively simple concept to understand, they're very useful and will add greatly to your React code. Another really useful ES6 feature is default arguments for functions. So in ES5, we could get default arguments, kind of, sort of. Let's say that we had an add function that took 3 arguments such as this, where unlike in other languages, JavaScript does not feature any sort of function overloading. So it won't be possible to have one add function that took 2 and one add function that took 3, right? This would be more of a Java style thing. We can't do this. The most recent one's just going to overwrite the old one. So what we're going to do is we're just going to find one function here, and regardless of how many arguments we call this function with, or any JavaScript function with really, it'll still work out okay. So if I say add with 1, 2, and 3, we'll implement this in a moment. It's going to print off all 3 of those variables. But if I leave one of them out, such as 3, like that, it's just going to put the value undefined for z. Furthermore, if I leave all the arguments out, it's just going to pad them all with undefined. And we can even throw extra arguments in there, and things still won't break down. Like so. Point being, it does this matching purely based on the function name and not on the arguments passed in. So prior to ES6, we could say, all right, if we only pass in 2 values here, for example, and we want x to be whatever its usual value is, but if y is missing, give it the value of 5, such that if we were to say add 4, that would be equivalent to add 4 and 5. If we were to say add 5 and 10, it wouldn't use that default value. It would just be add 5 and 10. And again, if we were to leave it out, it would be add 2 and 5. So whenever the second argument is missing, make it a 5. And before we could do this by checking for undefined, we can say if y is equal to undefined, because that's what it will be if the argument is missing. Y is equal to 5. and this will successfully get 9. And often there's a trick with the OR operator to make this a little bit more concise, where we'll say y is equal to y or 5. And what's going on here is the OR operator returns the value of the last expression evaluated, and it short circuit evaluates. So if y has a value, it'll retain that value. If it's undefined, it'll be set to 5. So that would work too. But the problem is, due to JavaScript having implicit conversions and falsy values, 0 can be interpreted as false. And the problem being that if we wanted to say add 0 here, because 0 is falsy, this will evaluate to false, and it will overwrite with the 9, even though we did supply a value. Let's print that out. Like so. So even though we had solutions for this in ES5, neither of the solutions is very good, because while this is concise, it has that edge case, and if y is equal to undefined, y equals 5 like we had before, is a little bit verbose and not very concise. So with ES6, we have a very elegant and simple solution, where inside of the parameters here, we're just going to say equal 5. And the nice thing about this y equals to 5 default parameter syntax is that unlike the OR trick, this will not overwrite the value of 0. So 0 will still be 4, not 9. And again, if we supply a second value, it will be as if that equals 5 wasn't even there, like so. While default arguments are useful and a great addition to the language, they don't help us out in the instance of having a variable length number of arguments. And to operate with those, we're going to use rest. And then spread is kind of related, so we'll cover it at the same time. Spread's kind of almost the inverse of rest. So many of you might know from ES5 code, let's say that we were going to define an arbitrary add function that will add however many numbers we pass in here. So on and so forth. And what we can do is there is a keyword called arguments that is an object local to that function. And whatever arguments we pass in, those will go through to there. So if we say add 3 different ones like that, we're going to see we have this right here. Something that's kind of unusual about this and worth taking note of is that even this is not actually an array. It is merely array-like. And the implication of that is that we don't have our usual array methods, such as map, for each, reduce, and so forth. We did have a little hack around this where we could still borrow from the array prototype, say array.prototype.map.call arguments. Actually, we'll do reduce. And return, say var result is equal to that, and return the result. Gotta delete this. Oh, see, and this is where I'm going with this, is while this is possible, it's a little bit tricky and easy to screw up, and the ending code is pretty long and complex. Like so, we get 9. So there's a better way to do this with ES6 rest. So we're going to go in here and we're going to create a better add function. And we're just going to say ... values. This values isn't a special keyword. It could be whatever we want it to be. And then let's take a look at that. So console.log out the values. And let's call better add with 2, 4, and 3. So unlike our arguments object, values is a proper array. This makes it much easier to work with. So instead of this weird kind of hacky array.prototype.reduce.call, we can just immediately say var result is equal to values.reduce, which most would say is quite the improvement. console.logging that out. And we get the same result. Another benefit to REST is that, I'm going to grab a new one for this, REST spread 2. Let's say that we wanted to have a pattern where we would have two variables that we expect to always be included, but then we have an optional list after that. Let's say we wanted to define a hello goodbye function that would take a greeting and a farewell and an array of names. Then for each person in that array of names, it would say both the greeting and the farewell to them. So greeting, goodbye, names, like so. And we can say names.forEach name, console.log, and do the same with, we'll do this one farewell. Farewell. And we can go in through here. Oh, give it a name. We'll call this talk. And we can say talk, hello, goodbye, Bill, Joe, Morty, and run that. And it went through with each one. So this works okay. But the part that's a little bit awkward about the API for this is ideally we wouldn't have to specify this second one as an array. Ideally, we'd be able to call it like this. Okay. We could try to utilize arguments in order to get us something like that, where we can say greeting, farewell. So we can get these two based off the first two parameters, and then we can pull the rest of these off of arguments. But the problem is, while greeting and farewell will successfully be hello and goodbye, if we take a look at arguments, in this case, oopsies. So go ahead and take this out for now. I'm gonna put it there. Oh, I didn't save the file, and I gotta do talk 2 right there. Where even though there were named arguments for greeting and farewell, they still showed up in our arguments object. So we could go in here and we could selectively filter out based on that. We could splice out an array and say array.prototype.slice.call arguments, transforming it into an array. Verify that for you all. And then instead of just slicing out the entire array, we could say, grab it from the second argument on, like that, where we have successfully made args include everything after the named arguments. This is even more gross and hacky than our first time using the arguments property. So REST is also better in this case because what we can do is we can say ... names here, because it's a very common pattern that will have some named arguments in the beginning and then an arbitrary number of arguments at the end. And for this version, let's create a talk 3 that utilizes that. We're going to go here and say names, and we can get rid of this because names will only include ones that came after the first and second argument. Like so. So we can write much cleaner code with that. That looks like this. Out of parenthesis there. Run it again. And same result, much more concise code. Now, a related operator to REST is spread. So we see here how this REST operator will take extra stuff and then it will pack it down into an array. Spread will do the opposite. Spread will take an array and spread it out into individual operators. So let's say that we had an array containing our greeting and farewell. This example is a little bit contrived, but I'm sure you can find useful ones as well. And we wanted to pass that array in here. So we could say array at 0, array at 1, but even more usefully, we can say ... array. And this time, instead of being the rest operator, this is the spread operator, and when applied to an array like so, it's going to unpack it into this, working in the same way. So a common place where this pops up in React is we will have components that will be creating child components, and when they do that, often they're going to pass some of their own properties down into that child component, and instead of having to create named versions for each one of those, we'll use spread. Additionally, REST can be useful when defining instance methods for our components. Next, let's take a look at one of my favorite ES6 features, arrow functions. Something that many people don't like about JavaScript is the function keyword, in that for something that you use so frequently, it's quite verbose. Additionally, whenever we're doing functional programming, such as numbers like before, it's kind of inconvenient to have this long function keyword in there. So ES6 brought in a shorthand for function, and we call them arrow functions. An arrow function version of, let's say we just had one that just created a new array that every one of these times 2. The arrow function equivalent to this will look like this. Numbers.map number. So this here is the new arrow function part. And the way that I kind of think about it is like this. So before we had function number. When doing arrow notation, we replace the function keyword with an arrow, like so. And then originally it was function parameters. Now we're going to make these swap places. So it's going to be parameters function, like so. And then after that, it's the same as it was before. So that's the basic form for arrow functions, but there's a couple little shortcuts for it. So here we have form 1, the most basic form. Typically, we would want to save the result of these maps, but since it's not the point at hand, I'm going to go ahead and delete that. Another form, form 2, is for when we have only one parameter. So here we only have one parameter, that being number, so there's a shortcut. In this shortcut, we can drop the parentheses, like so. Just have it like that, so it becomes number. Furthermore, we can also use these in a function expression context, not just anonymous function context. So we could have something like that, just as a little aside. That being said, this is exclusively for when we have one function, one argument. I'll do them up here. If we have 2, we must once again wrap in parentheses. So this isn't valid. We would have to go back to doing this. And furthermore, if we have 0, we must still use parens for 0 params. So if we had, this isn't a real function, but in theory, while useless, that would look like that. We would still have to have these grouping parentheses around it. For those of you that come from CoffeeScript, this will take some getting used to because this feature was originally inspired by CoffeeScript's arrow functions, and CoffeeScript had the opposite convention where 0 parameter functions, you could drop the parentheses, and 1 parameter functions, you still have to include them, okay? So another shortcut is for when we have one-liners. For example, if we were to say numbers.map number and make it all on one line, we can omit the curly braces, so we don't need these. Now, when using this, we can also omit the return. So in one-liners, we'll omit both the return and the curly braces. Now, more specifically, the fact that this is a one-liner isn't what's determining that. Is that this function body consists of one expression. So whenever we have a one-liner expression like this, it's unambiguous which expression inside the function we could want to be the return value. So we can go ahead and drop the return, and this little return is kind of implicitly there. Just to verify. Oops, let's go back and add numbers there. Run it again. Like so. In addition to being more concise and giving us the implicit returns when doing the one-liners, arrow functions also have powerful scope mining capability. So let's look at an example of that. So let's create a little constructor function here. And a place where this is very, very useful is in set timeouts. For example, let's say that we had methods such as this, say name timed. So let's say we had a function like so. Then inside of it, let's say that we wanted to periodically have the person say their name through set timeout. Then when we call p1.say name timed and run it, while everything appeared to line up before, we got my name is undefined. So why did we get undefined there when running this? Well, jumping back into it, recall that the rules for setting this are the dot, the new keyword, and bind, call, apply. And as we're soon going to see the arrow functions, and inside here, in this anonymous function that we pass into set timeout is going to invoke this function for us behind the scenes. And when it invokes it, it's going to be invoking it without a dot. That means within this function, this will not refer to P1. Because going inside the function from here, at first right here, this will be equal to P1. But then when we get inside of here, we're going to lose that context. And there's a couple of fixes for this. One of them is something like var self equals this, and then saying this dot name doing self dot name. That's because while this is dynamically scoped, other variables are lexically scoped. So with this trick right here, we're kind of simulating a lexical scoping for this, getting the proper result. So that's one fix that people have used. Another fix is to do a bind on this inner function, like so. While both of these tricks work though, neither of them is particularly elegant. A better solution is an ES6 arrow function, where if instead of using an old school anonymous function with a function keyword, if we define this with an arrow function, it will work without any additional tricks. And the reason behind that is while usually this is set using dynamic scoping, the rules we discussed earlier, whenever there's an arrow function, behind the scenes you could look at as if it's implicitly calling .bind this on that function, because with arrow functions, this will be lexically scoped like we're used to with most variables. So it's going to look at this here. It's going to go, okay, there's no this defined. We're in an arrow function, so let's check the enclosing scope. And in the enclosing scope, it's going to find this because this will implicitly be set to P1 because say name times will be invoked with a dot. So the dot right here inside the say time function will set this to P1. And then the lexical scoping of the arrow function will set this inside of this console log, working together to give you the proper value for this.
Another powerful new ES6 feature is destructuring. What destructuring is about is, before in JavaScript we can create multiple values in an array at the same time. But if we wanted to take each of these values inside the array and assign them to an individual value, it would have to be a four-step process. Say var x, var a equals array at 0, var b equals array at 1, c, and so on and so forth. Destructuring lets us pull multiple values out of the array, just like array creation allows us to put multiple values in. Another use that later on you'll see for this is that the new ES6 module syntax is very conceptually similar to this destructuring syntax. So if we were to take this array and use destructuring and do the same thing, we can do something like this. Where A is going to map to 1, B is going to map to 2, C will map to 3, and D will map to 4. Additionally, if we wanted to, we can skip over values. Let's just say we wanted the first and the third value. The way we do that is by doing this. So we still put the comma there, but we just leave an empty slot. In this case, A is going to map to 1 and B is going to map to 3. Another really useful feature about this is the ability to swap variables. So here, A is mapped to 1 and B is mapped to 3, but let's say we want to map A to B and B to A. Traditionally to do this, we'd have to have a temporary variable to do so, but with destructuring, we can do something like this. We can say AB is equal to BA. And this little semicolon right here, if you choose to omit semicolons in your code like I do, one of the few gotchas behind that is if a line begins with a bracket or a parenthesis, like so, in order to let the compiler know what you're talking about, you have to begin the line at the semicolon. This is really one of the only uses where I've ran into that scenario, so I personally decided it's worthwhile. And when we run this, we're going to see that A has the value of 3 and B has the value of 1. Right there, we swapped it. In addition to working with arrays, destructuring will also work with objects. So let's say we have a dog object, where the name is equal to Sparky, age is equal to 5, and the toys are equal to some rope and a bone. Now there's no sense of ordering with an object, so the syntax is, at least the vanilla syntax is a little bit more noisy than the array vanilla syntax. We can say var name, dog name, oops, have a syntax error right there. Like so. And what's going on here is we take a local variable dog name and we assign to it the value of name. It's like we're mapping property name to local variable dog name, mapping property of the object age to local variable dog age. And since arrays are unordered, we can take these and change the order around. So this order is also fine. Will not affect the value of our execution. And we don't have to assign to every property either. We can select just 2 of the properties, for example. Oops. Like so. Another nice feature is frequently we just want to create variables of the same name, right? So what I mean by that is instead of name to dog name, toys to dog toys, we might want to do name to name, toys to toys. And if and only if you're creating a local variable of the same property name, you can actually cut down on the syntax and simply say name and toys, where we'll create a local variable name mapped to property name and a local variable toys mapped to property toys. And truthfully, this version right here is the one that's more frequently used. If you're not careful, it's really easy to accidentally get these flipped. But thankfully, this is the one that I myself more commonly use. One last feature that I want to point out is that we can also do destructures inside of destructures, right? So, for example, if we had a nested array, we can go ahead and assign each of these inner array values to an individual array, like so. Where here, X maps to that inner 1, Y maps to that inner 2, Z maps to that inner 3. And then the second array, we're not going to do an inner destructure. We're just going to assign it to one variable. So other array will be of type variable. Oops. Still got to do this part. Okay. And not only can we destructure arrays inside of arrays and objects inside of objects, we can also mix and match these with as much nesting as we wish. So for example, here we have object dog with an inner variable arrays. If we wanted to, we can actually destructure out these toys individually, like so. Rope and bone. Where toys tells us the property, and then that value is an array, and we destructure the individual values of the array. There's a couple more odds, ends, and tricks you can do with destructuring. It's a pretty in-depth feature, but that is the basics of what you need to know to be dangerous with React.
While we've already discussed CommonJS, which you can use in your React applications, it's becoming increasingly common to use ES6 module syntax and to compile that down to CommonJS. So let's take a look at that. Inside here, we have a build process similar to what we've seen before. And we're going to open up this index.jsx file. And we're not actually going to do any React in here just yet. But let's take a look at this new syntax. So import React from React. That's the same as a named export. You know, in the other file is module.exports equals React, and we bring it in by saying var React equals require Reacts. So this is the ES6 version of this particular import style. Now, additionally, sometimes modules will export multiple things. Like let's say that we wanted to bring in a particular package from one of them. In that one, we would use curly braces. And we can see here when we had this React DOM one, for example, where React DOM exports multiple things, we can bring in the render in particular by putting it in curly braces. And the CommonJS version of that would look like this, as we've seen before. Additionally, while this isn't destructuring, it's very similar in spirit to destructuring. And let's take a look at that by creating a couple of our own. So let's say we did libfile1.js. In here, I can say function my library. And we have a couple different options here. If we were to say export function my library, this is how we would export multiple things from this library. So from here, we could export other functions, such as like so. And the way we would consume these is we go back to our index file, or whatever file we want to have bring these in, and we would say import, we'll get to this in a sec, from libfile. Since it ends in .js, we can take off the extension. And something to note is just like CommonJS, since we are doing one of our local files, we have to put a path. If you leave this off, it's going to be looking at your node modules for something called libfile1, but that's not what we want. We want to refer to our local one. And inside these curlies, we say what we want to bring in. If we want to bring in my library, for example, inside here we would say my library. If we want to bring in other library functions, instead we put in other library function. If we want to bring both in, we would simply go like this and separate them with a comma. And often if you're bringing in lots and lots of different libraries, it can be useful to break this down over multiple lines, like so. Notice how this is kind of like destructuring. For example, let's say we had an object that had, let's say, my library and other library function. We could destructure from this like so. So find that a useful way to think about it. Let's take a look at the other form, which is a default one, where instead for one of these, if we were just interested in exporting one thing, something that's common to do is to say default export function my library. And when doing it this way, we can leave off the curlies and simply go my library from libfile. Then, just like CommonJS, we don't have to export just functions. We can also do other types such as numbers, strings, object literals, and any other standard type. Next, let's take a look at new ES6 classes. And we're also going to be using these later on in React because React can make its components instances of ES6 classes. So the first thing to point out about classes is even though there is a class keyword, there are not actual classes in React. They're simply sugar around the typical prototype-based system. Nonetheless, let's say we had class person with a constructor. So person is still of type function, even though this looks like a more typical class-based system. If we were to run this, we'd see that we still have function person over here. And the equivalent constructor function for this would be like so. One of the real benefits to this class-based system is with constructor functions, we have to define their methods, typically outside on the prototype like this, which is a little bit awkward to look at because it's not located inside of the constructor function. So it can be a bit confusing that it directly relates to it. You really have to know JavaScript to know how these two relate. Whereas with class-based syntax, it's a little bit more clear. We just use say name like this. And there's also a little bit of new syntax here in that say name is a function. but we are creating this function on the prototype of person, and we don't have to use the function keyword, nor do we have to use an arrow. In the context of a class, the function part is implicit. Then inside here, we can say, just like we would for any other method, even though it's a class, we use it the same way as you do constructor functions, and the instances behave the same as well. Taking a closer look at this and unveiling how, yet again, this is still prototype based, is we can say console.log p1.proto is a property that points to the prototype of the constructor function that created it. So in our other version, when we had this, proto will point over to here. And as there's still a prototype behind the scenes, it'll also point to that for the class-based version. So we can say that and ask, is it equal to person.prototype? And we'll see that is true. They are equal to each other. And furthermore, we can ask, is p1.sayname equal to person.prototype.sayname? We'll see that's also true. And these still have the same interesting this behavior of typical prototype-based instances, where like we demonstrated earlier, if we say var sayname is equal to p1.sayname, sayname will no longer be referring to p1. So this doesn't do any sort of auto binding for you. It does, however, set strict mode. Notice how this is saying you cannot read property name of undefined. That is one variance. That classes will always run within use strict, which will set this to undefined. And like before, we can fix it using bind. And that's something we'll often be doing with our React ES6 classes, is binding their methods like so. Additionally, we can do inheritance much easier with classes. And this is one of the main benefits to them. We can still do inheritance with the prototype-based system, but it's been historically something that has rather complicated syntax. Interesting to get right. But here, for example, if we had class creature, say name over here, then we can have class person, which extends creature. And we can also have class dog, which extends creature. And first part of this is we're still going to have a constructor in here. Let's say that for people, we have name and jobs. Just has some variance. And if we want this code to run up here, we're going to have to use the super keyword. So before, this would have looked something awkward like creature.call, passing in this and name. But it's much simpler with ES6 syntax, where we can just go super name, which is going to run our newly being created object in the context of this constructor, setting up name. In which case, after that, we just go this.job is equal to job. Come back and finish implementing this in a moment. Then we can use this new person class, which extends from creature. By the way, even though we're kind of using creature as an interface and not a class, there is no real interface construct. Say var p1 equals new person Chuck Barber. Log out p1.name and also p1.job, as well as using this sayname method that is now inherited from the parent class, or fate class, we should say. And we can verify it's coming for that by going console.log p1.sayname is ask if it's equal to creature.prototype.sayname. We'll see that that is true. While you don't have to use ES6 class notation with React, it is kind of the direction the community is moving in, for one. And for two, it's nice because that way, when other libraries start utilizing ES6 classes that, libraries that use with React, you can consistently use the same class structure and semantics across your different code and not have library-specific class syntax. One of the most powerful and useful new features introduced by ES6 is promises. Promises are a powerful new construct to facilitate asynchronous programming. They can be used in both backend Node and front-end JavaScript. They are very useful throughout React, and in particular, we'll be using promises with the new ES6 Fetch API, which is also promise-based. But before that, let's take a little bit of a look at what things were like before promises and see what the alternatives are. Here, I'm going to create a simple script just to kind of demonstrate, a little bit more general case of the problem. We're going to be working with a Node script that will read in files. Now, to understand event-based programming in JavaScript, you have to understand a little bit about how the event loop works. So where asynchronous operations come into play in JavaScript is whenever your code wants to do anything that happens outside of your system, say something that's I/O bound or networking bound. In front end, this is typically going to be something like an AJAX request. In back end, this might be something like a file read or write or a database hits. So if we had a file we want to read in, say we want to read in our current file through Node and print out the source code, we could do something like bring in the fs module from Node. We can say fs.readFileSync is equal to our current file. And we can say console.log file.toString. And see, we have code here that all did was print out its own source code. So this is okay for small files, but if this file that we read in would have been thousands and thousands and thousands of lines long, the entire code would block on this line right here, and we cannot continue doing other processing. Even though JavaScript isn't actually doing much of anything here, because primarily we're going to be relying on libuv and other system libraries to be doing the actual file reading. That doesn't happen in JavaScript land, so to speak. So since JavaScript isn't doing that process anyway, and it's just waiting on it, it makes more sense for JavaScript to continue running other code and then come back to this when it's finished. Unlike most languages, this idea of async is built in as a top-level feature, and often you are discouraged from doing synchronous operations. It's something you have to kind of opt into. See how this is read file sync and not read file? The encourage API is to use the read file method, which is asynchronous. So with read file, this won't return anything useful. So if you do this, we're not going to get what we plan on, which can seem a little bit confusing at first. We get undefined because we aren't utilizing this for its return type anymore. Now, the proper way to do it with this is with a callback. Asynchronous operations in JavaScript are traditionally done through callbacks, which is a function that will be called after our asynchronous operation is complete and the current context is done running. We'll come back to that current context idea in a moment. But here, after this file is done reading, instead of returning a handle on that file, it's going to invoke this callback function with that handle. And then we can do console.log data.toString here. In traditional Node style callbacks, the way that we handle the error is actually it's going to put the error here as the first parameter and the data handle as the second. So we would do if error, perhaps something like console.log out the error. It's almost kind of like a try catch where the catch comes first. All right. So the second argument here, second parameter here is what's going to be popular with our data handle, which we'll grab down here. Run in again. Now we have the same result. So let's talk a little bit further about what I meant by the current execution context being finished. Any code that happens after this line right here, after this statement in particular, is going to be invoked before that callback will be ran. So notice if I do console.log 1, 2, and 3, these will always execute in order 1, 2, 3, unless some sort of error happens first that causes it to terminate early, but they will never process in a different order. 1, 2, 3, and then our source code printout like before. It's important to note that there's no sort of race condition happen here. It didn't print these off first because the file didn't finish being read in faster. Regardless of how long this process takes, even if it's nearly instantaneous or if it takes minutes, in any case, this is going to happen before the callback function is being ran. The current execution context, meaning the entire call stack, must finish first. So even if we had these inside of functions, say something like function main, function helper, and let's read in the file again inside of here. This will be a little bit more complicated like this. Scroll up, we see we have 1, 2, 3, 4 in all of our code printouts. And the reason it evaluated this way is because of the event loop ordering and the idea that all the current code execution context must finish first. So going through here, we read this bit of code first, and this callback function here, as soon as the asynchronous operation is complete and the current execution is running, this will be up next. I kind of like to think of the event loop as an event queue, really, where the current process is the first thing on the queue, and then this callback function will be the next thing on the queue. And this is a queue. It's non-interrupting. It's not based on which one finishes first. So even if we were to put a different one here and say that this one was a much longer script.js, even if this file read finishes first before this one up here, this first one is still guaranteed to have its callback function ran first because this is a queue-based system, not a who finishes first based system. This has the benefit of making your code more deterministic, but again, if you lay things out incorrectly, expecting the first one to finish to be the first one to run, this can lead into performance issues if you're unaware of it. So let's go back and finish our original read through though. So this is going to be the next thing on the event loop, cleared to functions. And then we evoke main. We're going to console.log 1. We're still in the current context in the event loop. We're going to invoke helper. Helper is going to run, it's going to put 2. It's going to read this file in, and then it's going to next register this callback function with the event loop. Now this function is going to return, pop back up here, and our current context is finished running. The call stack is completely empty, there's no more code to run, but we still have 2 functions on our event loop. We have this first one registered up here, and the second one registered down here. So we're going to run this one completely through, all the way done, all of its function calls, all of its returns till it's done, and then same with this one. And if you go through this again, that's going to give us the order. 1, 2, we're all done with that execution context. Start this execution context. 3, all done with that execution context. 4, all done with that execution context. Again, we have 1, 2, 3, 4. Another implication of that is if one of the execution contexts never finishes running, it's going to stall forever. For example, if we do while true here, it's going to log out 1. It's going to have this callback function registered, and the file may have been done reading ages ago, but it's still not going to run this callback function because the current function is not done running yet. It's just going to sit there and wait forever. The first issue with callback-based programming is that you have something called the pyramid of doom, which is if you want 4 things to happen asynchronously, this one, then this one, then this one, then this one, you're going to have to nest those callback functions, making this kind of ugly, weird, super indented pyramid structure. Let's see an example of that pyramid. So again, let's bring in the fs module, and let's say fs.read file. Let's say that we want to print out our old script first, and then we want to print out the pyramid scripts. In this scenario, it's not too bad because we only have 2 levels of indentation. And from here on out, just so we can tell what we're actually looking at, I'm going to, instead of actually printing out the scripts, I'm going to say script.js contents and Okay, we'll see that we did get them in the correct order. There you go, correct order. But if we were to keep doing this and say, all right, I want to print out script, pyramid, scripts, we'd have to nest this inside of here again, like that. And now we have yet another level of indentation. And if there's lots of lines of code in between each of these, it's going to get pretty unreadable pretty fast. The further and further we get in, the harder and harder it is going to be to keep track of. And furthermore, we had the issue that it's very hard to not only read this code, but make modifications to it. Let's say we wanted to change the order of these slightly. I wanted to have this one be yet another script.js. And currently it's printing script, pyramid, yet another. If I wanted to flop the order of yet another and scripts, I would have to swap out this argument, take this entire function body, which is only one line here, but could be arbitrarily length, transpose it up here, and then take the old contents from here and move it down here. It's a very error-prone process. The more of this we have, the more likely we are to make some sort of mistake when doing this copy. So what promises are going to bring us is a better way to manage this so that we can have more readable code and code that we can more easily change in the future, specifically the order of our asynchronous operations. Node doesn't have a built-in promise-based version of the FS read file, but that doesn't mean we can't construct our own. But before we construct our own, we're going to take a look at how we would use that module if it did exist, because it's a little bit easier to understand promises if you work with consuming them first and then creating them. If you hop right into creating them, it's probably not going to make a whole lot of sense to. So let's pretend that we already have a clean, nice promise-based FS module and use it, and then we'll go back and implement it. So at a high level, if we had this function promise read file, like so, in our old callback-based version, it would be file path here for the first argument and some sort of callback function with error and data in the second argument. What we're going to do, and it's not going to seem like anything revolutionary at first, but instead of this second one being a callback function in the promise-based version, we're going to do a method chain to the .then method. Inside that, we're going to take a callback function like so. So this doesn't seem too revolutionary, as I said, but the part that's nice about this and where we're going long-term is we can chain these operations where inside here we can return another promise, by which I mean an async operation, and we can chain it with .then data again, and we can keep doing this, and we can stay at one level of indentation the whole time. As we chain more and more asynchronous operations, we're not going to go down like this, we're going to go straight down like this, which greatly enhances readability. And we're also going to see that that allows us to really easily swap the order of them, well, without any messy refactoring. So this is how that they're consumed, but how they're created is going to look a little bit strange at first and a little bit unrelated, but let's break it down step by step. So first off, before we look into functions that return promises, let's work with some raw promises. A promise is an object with a constructor, constructed like so. Inside the arguments for this promise, we're going to pass a callback function with two arguments, resolve and reject. Resolve and reject will themselves be callback functions. And what we want to do is we want to have some sort of usually async code in here. You can do this without async code, but if you write promises without using async code, you're kind of adding a lot of complexity for no real benefit. We're going to do that at first, but in the real world, you're going to want to stick to async operations in here. What you want to happen is you want to call resolve if there is no error. You want to recall the resolve callback function, maybe with some data, maybe not. And if there is an error, you want to call reject. So just kind of hard code that in. We'll say var no errors equals true. If no errors, we're going to invoke resolve. Otherwise, we're going to invoke reject. Then what we can do is on this myPromise object, at any point in time, we could have even called it right after we created the new promise here. We could return this promise from a function and invoke it later. You know, we can do some stuff. And ultimately, we can say myPromise.then. with a callback function. This is going to look more similar to what we did before. And additionally, we're going to say .catch. What's going to happen is when this promise was created, if it ever calls the resolve method, like it did right here, when we call .then and asynchronous operation is complete, so this may be the next tick on the event loop, this callback function right here is going to get ran. If reject was called, this callback function will get ran. And if we open that back up and flip this to false, we're going to see that this code is called instead, and the catch line will be called down here. Failure. Nothing really asynchronous going on at this point. This is just a primitive that you can utilize for async programming. We're going to see everything here is happening synchronous. Console.log 1, console.log 2. This may be invoked here, but that's not going to happen until then is called. Console.log 4 and console.log 5. Oh, gotta flip that. 1, 2, 3, 4, 5, success. And furthermore, we could pass information through, like some sort of data payload here, which will then be put in here, where we can do something with it. Same with reject, we could put a payload here, usually an error object or a string describing the error. And we have the payload right there. So currently, while interesting, this isn't, the most useful piece of code. So let's instead work with creating a function that will return a new promise that does some asynchronous operation. So let's say vim fs real.js. We're then going to bring in fs again. Function promise fs file. And this is going to return a new promise with resolve and reject. And again, this makes sense because the API for this is going to work promise fs my file dot then. Unlike what we did in this prior file, while you can, save the promise to a variable and then invoke then on it at a later time, which can be useful. In fact, in the future, this is going to be used to help implement async await. Frequently and very often, instead of saying, var p equals p.then, you're just immediately going to invoke the promise object return from the function. And that's what we're going to do here. Inside this promise, we're going to actually do our async callback read file. So we're not really making the callback async operation go away. We're just wrapping it in an easier to use promise. So that way, when we use it many times again, we won't get that pyramid of doom. Read file, error data. And what we're going to say is if error, we're going to call the rejects from up here, our catch down here, passing in that error. Otherwise, we're going to call resolve with the data. So, and we can say console.log data, and let's point this at pyramid so we can see how much better this is in it. Oops, forgot parentheses. Okay, so we got to fix add arrow here. Oh, we got a buffer this time since we didn't call toString on the data. And there we are like before. So currently with just one callback, while slightly different, there isn't any real concrete benefits of this compared to a callback-based system. Let's go through the order of this one, just like we did with our original callback-based one. This with first line. This time we've wrapped this up in a function, so it won't actually be called until we invoke the function here, console.log 2. Then we're going to invoke the function here, bringing us up to console.log 3. We're going to create the promise right away. We're not going to reject or resolve it just yet because this is going to be put on the next loop. So far, so good. Console.log 5. Made it down to here. Because the function is going to start, but it's not going to finish because this is an async operation. So we're going to get down to here next. Then on the next tick of the event loop, we're going to be inside to here, giving us 6. We'll call resolve, which is going to bring us to here, console.log 7. And 1, 2, 3, 4, 5, 6, 7, just as we described in here. If you're a little bit unclear on this, I recommend going through, creating your own and tracing through it step by step to make sure you're really clear on the execution order. So while interesting and a little bit more useful than our first promise that didn't involve any async operation, we still haven't yet fully yielded the benefits of promises because we still have one level of indentation. And let's see where this is going to be useful now. And let's say promise fs real chained.js. So when we start chaining these, this is when it's going to get really powerful. Something I see people do a lot when they first start with promises is they'll go, okay, inside my then, this is just like my callback, and they'll do, let's go ahead and get rid of these logs, we don't need them. We go, okay, next I want to read another file. So I'm going to say promise fs.then, let's read in script.js, .then, data, in console.log out that data, .toString. Or put another way, 1, 2, since this is just for example purposes and we don't actually care about a particular file. 1, 2, 1, oops, we left a number in there from earlier. Then we're going to see this be 1, then 2, as expected. However, this works, but it's not actually any fundamentally different from a promise, because as we keep adding in more and more of these, we're just going to get another promise version of the pyramid of doom. We're just going to keep going in like this. So the proper way to do this is instead of invoking the then when using the new promise, we're going to return the promise object itself. So here we're still going to say promise fs inside of this then block, but what we're going to do is we're not actually going to invoke the then. We're going to return it. It's going to be the return type of this function call right here. Since that's the return type, we could chain it. Say var promise2 is equal to this promise that we did right here. Then go promise2 dot then something like that. Nothing wrong with that. But if we want to make this even more concise, we can just go ahead and invoke the promise right after it's returned by doing a method chain like this. Like so. Oops. Add out a parenthesis. Red, file 2 red. There we go. The cool thing about this catch block down here is that if either of these throws an error, and by throws an error, I mean if in this promise, the initial promise here, if its reject method is called, or callback is called, or if in this promise right here, if its reject is called, in either case, it's immediately going to jump to this catch block down here. So currently everything's running okay, right? It's printing off each of them. But let's say we point it at a file that doesn't exist. Let's say that I accidentally misspelled pyramid. No such file or open pyramid.js. Great. And it didn't print off the other file because it scripted right to that catch block. So let's respell this correctly. And this time we'll forget the S on script. Run it again. This time we'll read in the first one, but error out at the second part. One last thing we can do with these is make them a little bit more concise, but at the expense of potential confusion if you're not careful, is recall that one-liner arrow functions will return whatever their expression is. You remember back earlier in the video series when we did, where here this is equivalent to this. We're going to do the same sort of thing up here in our promises to make these really quick and short. So not quite appropriate here as we want to print these out, but frequently useful is to utilize that to get these nice clean one-liner promise chains, like so. We're here, we'll read in the first file, read in the second file, and then log out the data. Second file, and we'll even make our catch come along for the ride. Oops. Forgot the parenthesis right here. And there we have it. As you're going to see, even though this node FS functionality isn't promise-fied, so to speak, the new fetch API that we're going to be using has promises as a first level feature, so you won't have to wrap them up in a promise yourself. While there are many different ways to do AJAX requests, from the vanilla XHR to the very popular jQuery to various open source libraries such as SuperAgent, there is now a built-in high-level API for performing AJAX requests in ES6 called Fetch. Feel free to keep on using whatever you used before if you're more comfortable with it, but one of the benefits of Fetch compared to something like jQuery is, while jQuery brings in a whole library for DOM manipulation, a whole library for AJAX, you're not going to be using that DOM manipulation part while working with React. So this is a much smaller dependency. And for two, when using an ES6 capable browser, it'll already be there built in, so it's not really a dependency at all. But even when you do bundle it up for use in older browsers, Fetch is a much smaller dependency than jQuery in particular. So let's begin. There's many different things that you can do with Fetch, but to start off with, and for the purpose of this lesson, we're just going to do a basic GET request. But even though we're only doing a GET request, it still can do posts, set headers, all the fancy things you would expect out of a typical AJAX client. So over here, I have a node server running on port 3000. And on this path, just showing off a little AJAX request from the terminal, posts is going to give me this JSON response. And we're going to do this through Fetch instead. Just to give us something to boot up into, I'm going to use this little package called live server. If you don't have it, you can do it through npm install g. But really, there's not even anything in this index.html. I'm just running this through here so I have something to type it into. Go ahead and say live server. Go over here. Going to paste in the fetch command, and we're going to look at bit by bit. So notice that fetch is built into the window object because it's there in the browser by default on a recent version of Firefox. And here we post the URL that we want to go to. That returns a promise, which we call .then upon immediately. And this is a response object. From the response, we're going to say response.json, which returns another promise that we're going to chain with .then. The reason for that other promise is it actually returns a response stream there, and we're going to want to, end that stream and get the final result. So we'll call .then upon that. And then this contains our actual JSON data, which for now we're just going to console.log out. And we'll see that we have an array with two objects containing the same content as when we read it in from the terminal. Lots of great documentation on this online. Don't want to spend too much on it because many of you out there probably have your own favorite AJAX library. But if you're looking for something new, feel free to check it out, ES6 Fetch. Additionally, there's a version of it called isomorphic fetch, which isomorphic is a fancy word for JavaScript that can run both on the server and the browser. And if you go to GitHub and search isomorphic fetch, you'll see that there's a package for it right here. And when brought in through a require and CommonJS on Node, you can use the same fetch API on your Node applications in addition to the one that you use on your front-end applications. The next ES6 feature we're going to take a look at are generators. Generators are a new type of function that you can enter, go out and do something else, and then resume the function at a later point in time.
They are powerful for many different features, but the main reason that we're going to be looking at them is when we explore ES7's async await. Under the hood, those are implemented with generators and promises. So with that, let's look at a simple example of a generator. Where, to begin with, let's take a look at this one first, the silly generator. So the first thing to notice is this new bit of syntax, the star. The star has to be there in order to designate that this function is a generator function. The next thing to take note of is this keyword called yield. Yield works similarly to return, but unlike return, where once we've hit return, that function invocation is finished, yield means, okay, exit the function right here, but next time we invoke, let's resume at the next line after that. So if we're to create an instance of this generator, let's say sillygen equals silly. The first thing to note, and this might feel familiar if you have some Java experience or really any language that uses iterators, is calling this function here does not actually kick this off. Instead, what it does is it returns a generator object, which is assigned to variable sillygen. Okay. What we can then do to actually invoke this is we can call the next function of that. So if I say console.log sillygen.next, we'll see that we have value 0 done false. And I'll call that a couple more times. And we have the value 0, 1, 2, done false, done false, done true. And then after done is set to true, for all subsequent calls of next, value will be undefined and done will remain true. This might seem a little overcomplicated at first. You might go, well, how come when I call silly, it doesn't just invoke the function and give me the value? Why do we need all this, generator object and an object result with a done and a value? Well, the reason for that is even though they aren't of importance for our async await example, there are some other use cases for generators. One of them is they can be used with the new for of loop. So for example, I can say for let num of silly, right? Not a for in loop, not a for each loop, but a for of loop. It will wrap around that process for me, stepping through this iterator, assigning values to num until return is reached. Like so. Another example of a generator is this one up here, where we pass in a limit, count is equal to 0, and while true, if count is greater than limit, we'll return, otherwise we'll keep increasing the count. This is an example of an potentially infinite generator, right? Where if we passed in a limit, modify this a little bit. It'll go up to 30, right? You don't generally want a generator that is actually infinite, because then it'll never terminate, but you do want the possibility to be infinite. Pass in 5. We'll just go up to 5. And just for fun, if I do in fact pass in infinity, it will in fact go on for as long as possible, typically until your computer runs out of memory. So in these simple examples, I've just shown how you can get values out of the generator using the yield keyword. But what's really powerful with generators is not only can we pass data out of them each time, but just like we can pass in some data, every time we reinvoke the generator through next, we can pass data back in. So yield passes out value count, but we can also assign some sort of value into it, like so. Here's an example of a generator with some two-way communication, where when we initialize it, we get out the value y, which will be 3. But then we'll call next with 10, which we will pass back over here into x and log out 10 right there. Right, just tracing through this a little bit more slowly. Create the generator. When we call .next, that's going to start this. It's going to yield 3. Pause right there, assigning 3 to value y. Then when we call foodgen.next, this little value here is going to be the return of yield. Because you can kind of think of yield as two functionalities. One, it functions like a return, but additionally kind of functions like a function call, right? Because yield will return a value, that value being the next passing value of next, in this case 10. So x will be assigned the value of 10, which we'll log out right here. Then one final example of generators, just a little bit more practical, even if it's only practical in algorithm interviews, is we can use it for a particularly elegant implementation of Fibonacci numbers, where we have fib, start with x and 0, yield x, yield y, and then up to our limit, we can say x is equal to y is equal to x plus y, really definition of Fibonacci numbers right there, yield y. But then next time we call this function, whether it's through a for of loop or whether through it's manually calling .next, it's going to start us back up here and run through it again. So here's one to generate the first 10 Fibonacci numbers. And as it's a relatively efficient implementation, we can even bump this up a little bit. Right? Pretty quick, much faster than the typical recursive implementation. And with that basic understanding of generators, let's look at how we can combine them together with promises to show you some insight as to how async await works under the hood. While it's not going to quite match the real underlying implementation of async await, I think it can be useful to create a rough approximation using generators and promises to better understand how the async and await keywords operate. So going into here, I've created this, and I'm running this through Node. If you're running this through React, you won't have to do this, require isomorphic fetch. I just did that to bring it in here so I can run this without the React environment, where I've created a little function called Ajax and a generator function called user repo. And the idea behind this user repo function is you can pass in a GitHub username and a repo number, and it'll give you the name of that repo number, right? And this is a pretty common pattern in RESTful APIs where you're generating some sort of user interface where you'll have to do one Ajax call, wait for that response to get back, and then based on the result of the Ajax call, you will have to follow another URL and get that data. And what's cool about this is if we look at this code here, I haven't understand it quite yet, this is asynchronous code. There is no blocking going on here. It's going to do this Ajax call right here, continue on, do other stuff, and then come back and finish the job right here. This is pretty powerful because this looks like fully synchronous code, right? And again, this doesn't mirror the actual implementation of async await under the hood, but this implementation looks the most similar to async await as how you'll actually use it, right? If you were to take this and replace this star with async and yield with await, you basically have the real async await. Okay, so let's take a look at how this works. So for starters, I call the generator function with my username and my number, right? Username and number. And then I say user data equals yield Ajax this endpoint. So what happens here is yields inside of a generator function. This is going to pause, and it's not going to, the function won't continue again until the generator, API gen, until its next function is called again. But in the meantime, we will go ahead and we will invoke this function. So coming in here into Ajax endpoint, we're going to fetch that endpoint. The event loop's going to go on. We're going to get the response. We'll handle that response right here. Then, because fetch has a streaming interface, we're going to have to resolve it to JSON. And then here's where the magic is, and here's the part where the underlying implementation will handle it for you. What we are doing here is in our final handler here, instead of logging the data or handling the response here, we're calling API gen.next. So what we're doing here is we're taking that final JSON response and we're passing it back into the generator, right? We're taking this data and that data is going to be assigned into user data, right? Because yield operates both as kind of sort of a return and a function call. So it's going to call this Ajax function and it's going to return ultimately data, which we assign to user data here. From there, we do the exact same operation again, but this time instead of manually creating the entire URL, we just go userdata.repos URL, assign the value to repos, okay? And then we wrap things up by printing off the repo name. And we'll see that for my GitHub, that particular repo name is Angular Store. So that was a lot happening all at once, and it's a little bit tricky. So what I suggest you do is you watch the next section on the actual async await implementation, and then kind of flip-flop back and forth between the two videos until you can see the underlying connections. While promises and even traditional node callback functions are still alive and well, many people are opting into the new async await feature, especially now that async await is included in the most recent versions of Node and built into createreactapp. There's no reason you have to use async await, but many find it a more powerful, convenient way to deal with asynchronous code. So now that we have a little bit of understanding of it from the last section, let's take a look at using the actual async await implementation. Okay, like before, I'm going to have to require an isomorphic fetch. You will not have to do this in a createreactapp environment, just because Node doesn't have fetch in it at the moment. Okay, and then what I'm going to do is I'm going to say async function get repo. Right? Just like how with functions, we had to put that little star to designate this as a special generator function. With async await functions, you have to use this little async word before function in order to designate as such. And what we're going to do is we're going to say let response be equal to fetch And since this is something that returns a promise, and this is why it's still useful to know about promises and generators and all this under the hood, whenever you want to assign anything to the result of a promise, instead of having to use .then or callbacks or any of that, right, fetch returns a promise, simply put await in front of the promise. Okay. That still looks a little messy because recall that fetch returns a response stream. So let's say let data equal to, we'll once again await a promise, await response.json. similar to before. And now to finish off the functionality of this, oops, forgot one last part. And there we have it, some of the most powerful and easily to implement asynchronous code that reads just as if it was synchronous code.
So let's take a look at a basic React application. We're going to be using some boilerplate code, similar to what we made earlier in the series. And ultimately, we're going to be doing things with the new ES6 syntax, but there's still lots of code bases in the old ES5 syntax for React. There's still lots of examples in it. So it can be worth at least touching on how that works. So let's do that before we begin. And I'm in my boilerplate code right here. Recall the usual process is we want to take this package.json file and we want to install the dependencies. We're going to do that with npm install. And the reason that this can take a little while and it might seem repetitive having this all the time is recall that npm will default to installing a local installation of this. It doesn't use any sort of global cache by default. So even if you've installed React in a different project, every time you create a new React project, it's going to grab you a new copy of it. Depending on your system, it might have to compile some native components like it's doing for me right now, and we're all done. And the result from this will be this node modules directory, which has all of our dependencies. Also keep in mind that if we were doing this application through Git, if you had a Git repo that's keeping track of this, we would want to commit our package.json, but we wouldn't typically want to commit our node modules, and it would be expected that people who were to clone this project down would be reinstalling their dependencies. Also recall that inside package.json, it's a task manager for us, and we're going to run this dev task that's going to spin up our server over here on localhost 333, specifically our dev server. So over here in another terminal window, that's in the same directory as we are over here. In the background, I'm going to run npm run dev. And just like before, it's going to spin up our React code, serving up on localhost 333. We don't have any code that we're rendering yet, but it will be available here. And like before, we have Webpack, our package.json, but now we're going to be working more inside this app directory. This app directory is going to be where all of our application code actually is. Throughout the series, we'll be talking about different directory layouts and different project layouts, depending on the size of your application and what style of state management you're doing, whether it's Flux or just vanilla React or whatever. First, notice that this isn't a JS file, it's a JSX file, right? Because recall that React has this new JSX syntax that we're going to be compiling into regular old JavaScript. So taking in so far, we have import React from React. Inside the React package, there is a default export of React. That's why we don't have to have these curly braces around it. We're also going to bring in render from React DOM and React DOM from React DOM. If you're working with a really old code base, you might see only React. In fact, if you're working in a code base style, you'll probably see this in the old common JS style syntax, something like that. And what happened is that React used to contain React and React DOM, but with the advent of React Native, which is people using React to write code, to write applications for iOS and Android, and soon target other platforms as well potentially, They wanted to share code between the React native project and the React project. So React actually contains code that is agnostic between React Native and React Web. Originally React Native just used a forked version of it, so they have common code here. But any React code that is specific to the DOM or the web version is going to be from React DOM. That's when we need both packages. Recall, as we described earlier too, when looking over concepts in React, that React really doesn't directly depend on the DOM. The DOM is kind of an implementation detail. The ideas behind React extend beyond the DOM. So they've kind of taken this philosophy and this stance and even, carried it forth to the actual packages for the code. So that being said, React DOM is going to be what renders our React code into the DOM. So usually we'll be working with the virtual DOM and right in terms of that, but this React DOM.render function, which actually we don't even need this right here, is going to be what takes our code and brings it into the DOM. So it's going to look for a component called app. This right here is JSX. We're going to be studying that in depth in a little minute, but for now, just work with it. We're going to say var app equals react.create class. Okay, and again, we're using the old ES5, not the new ES6 syntax for classes. And it's going to expect a configuration object like so. The thing that every React component's going to need, regardless if you find it through ES6 or through this old syntax, is a render function. Also, we want this capitalized. We need this render function. This render function is going to be called both indirectly through here and when we have one React component create another React component, like let's say we had var my component here. If we were to create an instance of my component inside of our app's component's render function, it would be calling render of my component. So inside of here, again, we're gonna be looking in depth into JSX momentarily, but we're gonna write a little JSX that describes our app. So JSX looks like HTML, but it's not. It's technically JavaScript. This is where the templates, or what's kind of the React equivalent of a template, is going to be for your application. And inside here, we're just gonna do a simple one with a p tag that says, hello world, everyone's favorite, like that. And if we look over to here, we're gonna see that Webpack rebundled up our code. And if we go over here, our browser, it live updated to hello world. So we know that when app is getting called right here, it's running the code inside of here and putting that onto the screen, which it's doing that as actual DOM code over here. If we inspect, we see that we have this little div ID app p with some React metadata around it, but still our little underlying hello world p tag is right there. And if we put more stuff in there, it would also show up. Additionally, there is this React toolbar over here. While over here in the native inspector, we're seeing the actual DOM code. If we want to inspect the virtual DOM with our kind of pseudo components, our pseudo React elements like app, we can see that over here. And this looks a little bit more like our React code base. If we were to throw in one more of these arbitrarily, let's say we had a var x component that just returned p with the giant x in it. And we want to consume this component inside of here and get it rendered out. We can just do it like so. Another thing to point out real quick is JSX is different from HTML5 in that JSX is strictly XML based. In HTML5, you can leave out the self-closing for self-closing tags. That is not the case in React. In React, every tag must be properly closed or else it won't work. And what's going to go on is right here, we're going to render the contents of this component right here. So when this gets rendered out onto the DOM, this right here will be replaced with X. Okay. And again, looking over here, we see that we have just, native p tags over here. Well, if we wanted to preserve the original structure, looking through this, we can go into here and see it like so. And I'm in Firefox. React Developer Tools for Firefox right here. There's also a Chrome version that works more or less the same way. Very helpful for doing these sort of explorations. But the last part of this is how we get from here, this React components, over to here. And what is this div ID app? So we looked at this earlier, but we kind of glazed over it. We have React DOM.render app, and then we have document.getElementById app. So what's going to happen is it's going to look up in our actual index.html page this element, and then it's going to insert this component inside of it. If I replace this with X, for example, we're only going to render that component. So if we look over at our actual index.html page in our build directory, we'll see that this is all we have going on. The only real HTML we wrote is this div ID equals app, and this script bringing in our bundle generated by Webpack. So what's going on is we're finding this right here and injecting our entire React application into here. Typically speaking, you're just going to have one mount point. You're going to have one div with an ID, and you're going to place your entire application right inside there. We're only going to do this little process down here once, and it's going to be all our app consists of. But often, if you have an application that's larger, that maybe you're porting, some legacy code that you're porting to React, you might have, div original app here, and then at some point, you might have div ID equals React app, and React just consists of a subset of your application. And over time, it's going to gradually grow, potentially, unless you want to have a mixed React something else platform. But if you're trying to gradually convert your entire code base to React, this div ID app would be gradually creeping up into the global scope. Then not a terribly common use case, but if you wanted to, you could actually render more than one thing into here. For example, let's say we're writing some sort of site that lets you type in React code, and that site was also in React. We could potentially have two separate React apps, app and app 2. And down here, we could have one rendering app into app, have another one render into app 2, X there. And this X is being rendered in there by the first app, and the second one's over into here. And again, if you're constructing a new React website from scratch, you'll generally just have one of these in one bundle. But if you're doing different things, it does have the flexibility just to make a part of your site a React application. Something that used to be a common pattern as well is instead of rendering the entire thing into a div tag, like we had before up here, for a while, people were instead going, all right, I'm just going to make the entire body tag the mount point and say, render my app into documents.body, like so. And as we see here, that will work okay, but it's actually going to generate warnings inside of React. Where warning, rendering components directly into document.body is discouraged since its children are often manipulated by third-party scripts and browser extensions. This may lead to subtle reconciliation issues. You don't want to do this because even though it will usually work, depending on what extensions you have and other plugins, it might be inconsistent. So for a more consistent experience, go ahead and always render into a div, an ID, or a section, just something that's not the overall top body element. Next, let's take a little bit more in-depth of a look as to what this JSX thing is. So opening up the file we had in the last subtopic, we'll see that we have what appears to be HTML right here. So while it appears to be HTML, it is not actually HTML. We could replace this with real JavaScript by saying React.createElement P, like so. Then just to verify that I'm not selling you snake oil, we'll make this one a little bit different. And we'll see that now it added exclamations to it. So this React.createElement is what's actually going on behind the scenes. Whenever we take our JSX files, here like our index.jsx, and our Webpack compiles it through this little React preset, it's getting rid of all of that JSX syntax. That's the name for that little HTML looking stuff like this inside of our React code, and it's converting it to equivalent React.createElement statements that the browser can run directly. So the syntax behind this is when you do React create element, first we take the element type here. This is the content of the element, and any attributes would go here as a key value pairing. For example, if we were to set a class on it, here we had something like this, then this little class name right here would have gone inside of here. So just like in regular HTML, sometimes our content of our elements will be text and other times it will be other elements, right? We might have a div that inside of that div, it says H1, welcome to my site, some content like this. Here's where JSX starts having a little bit more of a value added because we could translate this to a React.create element version, but it's going to get a little bit more messy. We're gonna have to start nesting things, right? First we'll have a div here. This is gonna be back to an empty object. Then instead of text right here, we're going to have an actual component and try to make this look a little bit more laid out, but it's going to get a little awkward. Create element, H1. Then this one is going to be another child of that one. So we're taking an array of components like so. So again, it is possible to go through and not use any JSX with your React sites. You know, you could use underlying React.create element, but this gets pretty awkward looking pretty fast for one. It gets tricky to do the deeper nesting. Secondly, often if you're working with designers and non-software engineers, they're gonna have a really hard time jumping into this, while the JSX looking stuff down here, they can hop right on into it and be good to go. It's a lot more simple for them to dive into. So technical or not, most people find this far more readable, far more parsable. And pretty soon you'll naturally start looking at this and kind of translating it mentally to the underlying React.create class. And an additional got you though, the only real problem I see with people doing JSX is they'll try to do stuff like this. So when we just look at this block and imagines HTML, it doesn't look off, but when we try to render it, like often happens with the front end, we don't see anything at all. But if we open up the console, thankfully newer versions of React actually give a pretty handy error here. Adjacent JSX elements must be wrapped in an enclosing tag. So that tells us to fix this element, outermost element, is a sibling to this one. So if we want to do something like this, we'd actually have to wrap them both in a div like so, or some other tag. And the point being that we are still returning something, because this is still a function, we can only return one JSX element. And that makes sense, right? Because behind the scenes, each of these is React.create element. And it wouldn't make any sense to do React.create elements stuff. And again here, this isn't valid. That's also just like trying to do, you know, in non-React, return 2, 4, right? It doesn't make any sense. So since functions can only have one return value, which if we want to return multiple things, we just make those properties of that one thing return. Similar with JSX, we have to make sure we only return one component. The other gotcha is sometimes I see people get thrown off by these parentheses here. And the point for that is if you were to write code like this, JavaScript's going to return right here and not even get to down here. So if we want to break a return over multiple lines, we're going to need to wrap it up in parentheses. And that's why with our JSX, we do it like so and return everything wrapped up in a div or a section, and we'll be good to go. And one more thing, just to really drive home the fact that we are doing React.create elements here. We could even do something like var elements is equal to all of this and return elements. Same as before. Well, typically, we're going to want to make our React applications and components as stateless and immutable as possible. State is still unavoidable and a useful and vital part of any React application. So next, let's look into how we are going to create state for our components using the ES5 syntax first, then the ES6 syntax in the next lesson. And additionally, how we can render this state out onto the document through our JSX elements. So again, let's open up the hello world file we had before. Let's get this guy out of there and see that we have hello over there. Let's go ahead and render into documents.getElementById app. Get rid of that error. Great. So let's create some state for this app. Let's say that we were making a site with profiles and we had a list of profiles that we wanted to render out. Say, I'm going to use the HTML5 section element as well, because it's a little bit more semantic to what I mean here. Section, profile 1, profile 2. I should make these 3. And we'll say name is David. So this is David's profile. And we can say that this is Sarah's. Render this out. Okay. We're going to be gradually making this more modular throughout time, but if we were to show the final version of these concepts initially, it'd be a little overwhelming. So let's go there bit by bit. So for one, this could be state inside of our application. These could be profiles that we dynamically brought in from a server and then rendered out. And what's common to do is, these days with single page application architectures, people are developing their front end separately from their back ends, and we can mock the data out inside our front end application. So we could just say var profiles and put the data inside of this array right here. But we're not going to want to do that, because if we put the state inside of there, React won't be managing the states. So instead of putting it in here, which React managing the state, recall to the way that the virtual DOM works, whatever set state is called will trigger a re-render. So instead, we're going to want to put it inside of here, inside of this create class. And when working with the old React create class syntax, we put a function, say, inside our configuration object called get initial state, like so. That's going to be a function. And what it's going to do is return an object describing the initial state of our application, or our component, in this case, our application. And in here, we can say profiles is equal to an array, and we'll have an object specifying each one. Right now, these are pretty simple, boring profiles, so just going to be names and nothing else in there. Like so. And then what we can do is this component will have a property called this.state that we can look at. So if we console.log this.state, go back over to here, look at the console. We broke some things. We forgot the comma right here separating these elements. Going back over to here. Rendering like before, but that's not really the point. What is I'll be a little bit more clear and say console.log our state and our state. Look through here. We'll see that we have this object which contains both of the things that we set inside of here. So by setting this up inside of get initial state, instead of doing something like, var state and doing it up here, it made it live on the app component itself. Next up, we're going to talk about how we want to render this information out into our templates. So before we talk about, even getting these out there, let's talk a little bit more about JSX. Something that we didn't cover before is that we can have JavaScript expressions inside of our JSX, which is a little bit weird because I basically just said we can have JavaScript inside of our JavaScript, but it'll make sense when you see it in action. So let's take this and put it off to the side for a moment. And what we can do is, let's say we just had P, some math, 2 plus 2. If we look at that, we're actually going to get 2 plus 2 rendered out to the DOM. But if we wrap anything inside a JSX tag, if we put it inside curly braces, it's going to be evaluated as an expression. So here it will evaluate this expression and print it off over there. We can also do things like if we had a variable, like so. A very simple expression would just be evaluating one variable, like so. And we can even do fancier things in here, like put in ternaries. So we can say name equals Bill. Fairly arbitrary expressions can go in these. We can break them down over multiple lines too, although frequently these little JSX expressions will lend themselves well to one-liners. Another thing that we're going to do with these will enable us to actually write comments inside of our JSX. It's going to look a little bit hacky at first, but if we had a bunch of elements in here and we wanted to write some comment, this is going to cause the JSX to parse incorrectly. Well, not quite incorrectly, but it's going to render it out and not give it as a comment. Additionally, this style won't work either. What we can do is, since we can have fairly arbitrary JavaScript expressions, if we put this comment inside an expression, which is a multi-line expression in this case, it will work. We see that it's not rendered out. And later on, we'll be looking at more complex expressions, and also take note that even though we can put basically whatever we want inside of here and inside our JSX, usually we want to keep these pretty short and sweet because we want to maintain some form of separation between our logic and our templating / presentation. So try to keep these pretty brief. But what we're going to use them for currently is to render out this information. So going back down to before, we could go up here and say, instead of name David here, we can evaluate our component state and say this.state.profiles0.name. Same as before, except this time we're reading it from state. And additionally, we can grab this guy, put it down here, and instead of 0, make it 1. Now the page will reload, and we're grabbing both David and Sarah dynamically from the state instead. So yeah, while better, this still isn't very dry because this is repeating here, the same structure. So what we're going to be looking at later on is how we can take this, isolate to its own component, and use the map function that we looked at earlier to dynamically generate a list full of these components. Well, it's good to know how the ES5 syntax works for React. Let's now take a look at the modern, increasingly becoming more idiomatic ES6 version. So like before, I have Webpack serving up the app on a different tab. And the first thing that's going to be different is instead of React.createComponent, we're going to use the ES6 class. And what's great about it is this is just the same vanilla class structure that we talked about in our ES6 intro. You know, no new constructs, nothing to keep separate, nothing React specific, just nice standard JavaScript. And in here, we'll make a constructor later, but for now, let's just make a render. Return. And same as before. So before we had, for setting the state, we had a lifecycle method called getInitialStates. But when we're using ES6 classes, there is a more ES6 classy idiomatic way to do it, and that's to set up state inside our constructor function, like so. Now, important to note, whenever you do use a constructor function, you have to make sure to pass props in. We haven't covered what props are yet, but just know that this is important to making things work correctly. Say super props. Basically, when we are creating our own constructor function, we're overriding the original constructor function from React.component. And inside its constructor function, there's some initialization that it must do with props to make sure things are working correctly. So if we're overriding that functionality, we need to make sure that ours is calling super to keep performing it, or if things are still working. And then next, we're just going to set this.state equal to our initial state. So if we had something that similar to what we had before, we can have profiles. And like before, we're going to wrap this up in a div since we're returning multiple components. Make sure to make this an expression. And we can make another one for Bill. Same sort of constructs as before, just a little bit different of a syntax following idiomatic standard ES6. So let's open back up the app we were working on a second ago. And instead of just rendering out these very simplistic names out to p tags, let's build out these profiles a little bit more and create a template for them. So let's say that in addition to name, it had an age and maybe even a list of hobbies, something like right. So then let's say that we want to take each of these and represent them something like H3 with the name. I should do a bio too. Fairly basic one, each of them, and that array. Where we want that, we want a paragraph tag saying Bill is 40 years old and enjoys long walks on the beach. And then finally we might want to say hobbies and give a nice list of those. See how that looks? Okay. So what we want to do is we've basically just made a template, and instead of having to copy this out and put it in place for each one, like we could have replaced this with states and kind of copy and pasted it for Sue. We're going to want it to be reusable, right? This comes back to that idea of defining new elements. So what would be a simpler way to do it is, instead of having all this, if we're to say, give me a profile element and give me another one for Sue. If we had some sort of magical HTML profile element that could create all this for us, that would do the trick. And furthermore, we'd have to give some information to this. While attributes, key value pairings inside the opening tag have special meaning for DOM elements, for the most part, when you create your own custom React elements and components, you can set up fairly arbitrary key value pairings. So if we were to have this magical profile component, we could pass into it name equals this.states.profiles.name. And also we'll see that here we're using expressions inside the attribute of our JSX. We can use it inside there as well inside the content. And we would go through and we would do this perhaps for each one of these attributes. And another common pattern, since this would get pretty verbose, is we can either break it down like this, do one for name, one for age, etc. Or we might even wrap all up into something like data equals this.state.profiles at 0. Something like that. All right, let's go and create this profile React component first. Sure thing is working. Okay. So what we're going to do is we're going to go up here and we're going to say class profile extends react.component. And something important to note is, if you're familiar about function statements versus function expressions, you'll know that these are not hoisted. Well, these are. We can consume this from anywhere in the file. So that means that if we want to use profile, as in the profile component inside of our app down in here, we're going to have to make sure that we declare it before app in our source code. So if we're going to take this and drag it down here, app will not have access to profile. So let's finish defining this. And here we're going to say render. Don't need a constructor. And let's take this template that we designed down here, yank it into here. Whenever I write React code, I like to verify frequently that it's working. Through here. Forgot to hit return. There we go. And now let's take this hard-coded data in and instead read it in from props. So we haven't mentioned explicitly about props yet, but let's talk a little bit about the differences. So components can have both state, as we set up here, and properties. Properties are immutable, while state is mutable. The idea behind props is, if you wanted a component with different properties, let's say that we wanted to find a new profile that had different props, we would simply throw away the old one and create a new component with the properties that we desire. A really common pattern in React is that you'll have a parent component that manages state, such as we have here, and its state becomes properties for its children components. So we're going to pass in all this state up here, which again, we've hard-coded in for now, but in a real app, we'd likely get that from a backend. And we will pass this in as properties to each of our profile components. And let's say down here, instead of this, we're going to have this .props.name. Place this one out too. Place this with our bio. And then what we're going to do here is we're going to do something a little bit more dynamic, but we'll come back to that shortly. Actually, we'll say that right now. So what we can do, let's say let hobbies, and we can go through using map all the different hobbies from this.props.hobbies.map. And we're going to return that hobby wrapped up in a JSX element, like so. Specifically an li, because we're going to be rendering this inside this ul. Like so. Hobby is going to be a string, and we're just going to nest it between an li component. And then the return value of hobbies is going to be an array with JSX elements inside of it, such as this. Then what we can do is React is smart enough to know that if you ever try to render an array of JSX elements like this, so we just took this array right here and rendered it inside an expression, it's just going to sequentially render each one of those ones. So this is kind of like a syntactic sugar for, not exactly syntactic sugar, but it's going to go through and do the same as this would do. Just going to render out each one of those adjacently in order into our ul element. And here we created LIs, but this is just a common pattern whenever you have a repeating component from a list. We could have also generated p tags this way, divs, whatever really. And for the last part of this, let's actually go ahead and create a profile. And we're going to pass it in the properties name, hobbies. We didn't actually put age in there. So let's go back and put that in there. Like so. And to make it a little bit more readable, we're going to break this down over multiple lines. So we're going to say name 1 equals this dot state dot profiles adds 0. We can go through and do this for each one of these. Later on, we're going to start using the ES6 spread notation to make this a little bit cleaner, but not to introduce too much at once. Sometimes let's make this in the same line like so. Let's take a look at that. That did render it out for Sue. We could do the same thing for profile too. I have to wrap that up in a div, so that way we aren't returning adjacent elements. Sue and Bill. To make this even a little bit better yet, similar to how we dynamically rendered out all of the hobbies here as LIs, we're going to go down here and we're going to dynamically iterate through the profiles list and get an array of profiles up here. Okay, then we'll get rid of this. Delete those two. Okay, so the issue is we got to go through here and we must make sure that we return from this map, kind of like how we have to do that down here as well. And now we're getting the same site that we had initially, but in a much more modular and repeatable manner. So far in the application we've been working with, we've split out these statically created templates into dynamically defined ones. Next, let's demonstrate how we can create new profiles. So looking at our code before, showing you where this is going to go is we're going to create a new add profile component, and we're going to have it modify the state of app ultimately. For the purposes of this app, it's small enough that we could just modify it in here inside the app component itself. But I want to demonstrate the pattern of children components triggering state changes in parent components. But before that, let's go ahead and make the state change occur within app itself. So in addition to rendering our current profile, we could also render a button and a form where the users can enter in new information to add another profile to this. And it wouldn't be difficult to make it with text boxes, and we'll do that down the line. But in order to make things a little bit simpler for now, we're just going to make it so that when you click a button, it's going to add a hard-coded user to this list every time. Later on, we'll be making this a little bit more dynamic and showing how you can get that through text fields. Doing that currently would introduce a little bit more complexity I don't want to bring in just yet. So going back into this, let's create button down here at the bottom. When clicked, it's going to add a hard-coded user, Tom, into our list of users. I'll have to profile better though. So in order to do this, we have to add an on-click attribute to this button. And what's going to happen is when that's clicked, we're going to register a callback function that will be invoked. And I'm going to make this callback function a method of our app component. So notice I said this.addUser right there. So React doesn't actually use right here the native browser events. It has its own synthetic event system on top of native browsers. This allows it to kind of, bubble over those eventing inconsistencies across older browsers. So even though we're working with, fake React synthetic events here, it has a similar API to normal events, where instead of E right here, E short for events, referring to the button itself, it's going to refer to an event object, and that event object is going to have a target, where instead it's going to have a target where e.target is going to be equal to this button that triggered it. And then kind of like with native input fields, if this was an input instead, say a text input, e.target.value would equal the text of that input box. So we're not going to use this event yet at this point, but just know that inside this callback function, it will pass that in if we choose to accept it, which we will be using later. Then inside here, we're going to add to our states a new user. Soon this user will be built in from a form, but for now, just to demonstrate, we're going to hard code in a user. So then we're going to take this user, and conceptually speaking, we're going to go this.state.push user, but this isn't actually what we want to do. Because while this will add it to this.state, it's not going to trigger a re-render. Recall the way that React works is it doesn't employ watchers for its state. This allows it to have much greater efficiency. It doesn't constantly do dirty checking and querying to see if any of its state has changed. Instead, what happens is whenever this.setState is called, that's going to trigger a re-render. So in order to trigger the re-render and modify this state, we're going to do this.setState, and we're going to pass it in an object. So this object right here that we pass in is going to be merged with the original state object. Wherever the properties conflict, the new object will overwrite it, but wherever there's not a conflict, it'll leave it alone. So for example, if in here in this.setState, we said profiles equal to an empty array, all of these profiles will be gone and empty array will be in its place. But if we had a metadata attribute here, this would be left alone. It's only replacing profiles because that's where the only conflict was. Any properties that weren't there before, we left alone. This is handy because if they didn't do this, often you would find yourself having to perform your own object merges when you're set state. So what we're going to do is we want to keep all of the old profiles, right? So we can't just do this, because what would happen then is we would be overriding Sue and Bill. But what we can do is we can say this.states.profiles.concat with an array containing the new user. It's important that you use concat here and not push, because even though when we said earlier that this .states.profiles.push user is kind of conceptually correct, the issue is what we return from the push method is the length of the array. So if we had a 2-profile array here and we push a new one on, this would return 3, and it's this return value right here that is overriding the original value. So if we use push, this will be replaced with 3, which isn't what we want. Concat, on the other hand, actually returns the new array produced. Again, React is much more about functional immutable programming. So instead of modifying the initial array inside the object, we're producing a new array. Okay, gotta add a curly over there. Oopsies, we accidentally rendered the button twice though, because of the way we set this up. So let's change that real quick. We don't actually want the button inside of here. My mistake, we want it down here. Okay. So we're gonna see here that when we do this, it appeared to be all wired up, but it's not working yet. Let's take a look at this. So down in here, we assigned onClick to this .addUser. Let's go inside of this addUser function and look at the value of this. This is null. That's interesting. And the reason behind that is right here, this addUser method, we are plucking it off and assigning it to onClick. So inside the onClick code, it's actually losing context of what was to the left of the dot. We're losing the fact that this addUser method was created by this component. So the way we fix this is using that bind technique we learned in our JavaScript review, and then saying .bind this and passing the bound function as the callback for onClick, such that this time when we go through, it will work okay. Now, another pattern that's arising, because even if you know about this issue, it's very easy to forget to bind it before you pass it down. And it's a little bit hacky, but there's not a better way to do it yet. There's some new ES7 features coming out that might make this a little bit better in the future. But a pattern that is arising is, instead of binding down here, what we'll do is inside of our constructor, in addition to invoking our parent and setting up a state, we're going to go through and for our instance methods, we're going to bind them. So we're going to say this.addUser is equals to this.addUser.bind this. That way, whenever we pass this addUser function into an onClick, it will be properly bound. Additionally, very soon, instead of calling addUser on the app component itself, we're going to be passing this method down as a property to a child component and calling it there. So we'll see this solution also works. So what we're going to do next is, instead of triggering this re-render from this.addUser within the app component, we're going to pass that addUser method down as a property to a child component. Then that child component is going to invoke that function, triggering a state change. So state management in React is a big topic, but one of the most common patterns is to have parent components manage a state of the children components. Currently, if we look at the code we had before, we have all of this state up in the parent component related to profiles right here. And it is setting the state itself right here and through this button. So long term, we're going to be adding text fields to give all this information instead of just hard coding it in. At that point, if we were to have a whole form inside of here with, input after input after input, then our app component will be getting a little bit too big and monolithic. So let's go ahead and create a new class called add profile. Additionally, this file itself is getting pretty big. So now is a good time to also start modularizing our code into different files. So inside our app directory, let's go ahead and create a components directory. Inside of our components directory, we're going to create one file for each of our components. So we're going to create an add profile app.jsx, a profile.jsx, and even an app.jsx. Now, if this application were a little bit larger, for our purposes, it'll be sufficient to just group all of our components together within app. But potentially, as our application were to get bigger, we might start taking some of that business logic out of the components into another directory. And even within this components directory, we might say profile components or something and place all components related to profiles inside there. Again, though, it's all about choosing the right layout and the right architecture based on your app size. And currently, this will be sufficient. So going back up the level, let's take a look at our index file. And to start with, let's pull out profile right here and bring it into its own file right here. So do that. I'm going to grab this code here, going to delete it from my index.jsx file and paste it into my profile.jsx file. Additionally, I'm going to use ES6 module syntax to export this. Export default in front of it. And then up here, I'm going to say import profile from, where here, recall, these are looking at node modules since I didn't give a path. I'm going to give a path here, components, profile.jsx. If you're interested in doing so, you can set up your Webpack so they can auto-resolve JSX files. By default, though, you can only leave out the extension if your file ends in JS. And since we did the default export right here, we did not have to wrap this in curlies. Okay, so let's do that and see if we're still working. So it's not loading. Let's see what the issue is here. So a couple things. We accidentally put default export when it really needs to be export default. Additionally, we're extending React.component, but this file we're in right now doesn't actually have access to React.component. So we're going to grab this and bring in that dependency. And now when we reload, it'll be working like before. Great. So let's keep going. Instead of building up this new add profile component within here, let's go ahead and create it in its own file. Like so. Okay, let's go ahead, export default class add profile. And let's go ahead and say import add profile from there. And this is usually what I do, since as you saw before, when you screw up your exporting, it can be a little tricky to debug. So before I even go and do any other code, I like to verify, because lo and behold, once again, we didn't bring this in. And it's nice to catch that nice and early. There we go. Let's begin actually defining this component. And what we're going to want to do here is, for now, we're going to take this button and instead put it inside this component. Later on, we'll do it for them. But a couple changes we're going to have to make. So for one, instead of rendering the button here, we're going to bring in add profile, and we're going to pass it a prop called add user. Could be a different name, but we're just giving it the same name as the method on the original app component. And we're going to pass it this.addUser. Let's make sure that it's still bound. Yes, it is. This is another opportunity for the binding to screw with you. So let's fix that, make sure it's there. All right. So now what I'm going to do is, instead of calling this.addUser from here, I'm going to call this.props.addUser. Delete this from here. And I'm going to change this text to add. Oh, running from the wrong server. 7.4. Every now and then you have to restart the Webpack server. Generally, it's pretty solid though. All right, we see over here we still have our old add new profile text from right here. Because while we've made this component and while we've brought it in up here, import add profile, we aren't actually using it. So let's go ahead and swap this out with add profile. And we're going to say add user is equal to this.addUser, which we already properly bound in our constructor. Give that a go. And now we're in business. And unlike before, we don't have one giant component. One last thing we're going to do is it's becoming a common structure practice to have this little index.js file really do nothing but bring in your main profile and load up your router later on and inject it. So let's make this just a teeny bit more modular by going into our app.jsx file, taking this big ol' app component, dragging it down into there, taking these dependencies, pasting them in there. Now we are actually inside the components directory, right? Because app is inside there, so it doesn't need to refer to the components directory anymore, so we can change these paths to that and to that. We're going to say export default components. Break. React is not defined. We actually no longer even need the React dependency in here. Go ahead and add to there. And now everything's working like before. I lied. We do also need this one in here. And now everything's working like before. And we have a much more modular, maintainable application. So far, we've been using a button to add a hard-coded profile. Next, let's take a look at how we can use input elements to actually read in each individual part. It's not terribly challenging to use input elements with React, but there are special considerations that must be made, and it works a little bit differently than traditional vanilla input elements. So let's go into app, same app we had before, components. So let's take this add profile, go into it. And what we're going to do is we're going to add inputs for name, bio, and hobbies. So first off, let's add one in for name. Just going to take this and drag it down here. So unlike buttons, which have on click, inputs are going to have on change. Just like on click, it's going to take an event handler, but instead of happening on click, it's going to happen on change. That means every character we type in is going to run this function. Additionally, we're going to supply a value field. Now, what's going to happen with this input that's conceptually different from a standard HTML input is typically inputs will manage their own state, but we want React to manage all the state for this application. So instead of input being, vanilla one, it's actually a React controlled input element that has React managing the state of that input inside of a component state. So what we're going to do is we're going to add some state to this component. So we're going to need a constructor. Don't forget to pass in props called super props. And in the state, we're going to have something for name, bio, and hobby. At creation, we're going to allow them to enter in a single hobby, keep things simple. What we're going to do is we're actually going to pass this state into the value property of our inputs. And we're going to have this onChange function right here call a method that we're going to define on our add profile component that will update this state. It's going to seem like a lot more effort than traditional input component at first, but we're going to see that it fits in much clearer with the React system, is going to make things much more simple in the long run. Because if you're ever falling back to jQuery or, querying the DOM directly, trying to go into the component and pull its .value without the React, you're kind of swinging upstream from React, and there's a better way to do it. So to start off with, let's create one for name. So its initial value is going to be this.state.name, pulled in from right here. And on change, we're going to call this.handleName. Let's go ahead and create a handle name method. And let's also say this.handleName is equal to this.handleName.bind this. Now, just like with inputs, there is a synthetic React event that will be emitted and passed in through here. But unlike with buttons, This time we're interested in that event element. What we're going to do is we're going to pull the input value out of the target of this event and call setState with it. So we'll say this.setState, because we want to trigger a re-render, give it an object. And in that object, we're going to say name is equal to e.target.value. And as we're typing here, you can't see it, but this input element is actually being re-rendered each time. And I could prove this by, if I get rid of this handle name setState, like so, we're actually going to see that I can't type in any text here. Right now I'm typing, but nothing's going through. And that's because what is happening is value is initially set to blank. OnChange is being triggered, but the state is not being updated. Now, when I have this in, what's happening is we're getting a nice little circular flow. I'll type in a letter here into the input. That's going to call setState, which is going to call render again, creating a new input with that new value. To further demonstrate that this is the case, we can do something like, say, span value of input is equal to this.state.name. And see how over here, this is updating in real time as we type into the box, verifying that in fact, this render is being re-triggered each time we enter in a letter. So recall that the way that reconciliation works in React is that when we change a component here, it's not going to affect its parents. It's only going to re-render that component's children. So right now, if we're to look at the structure of our app, this is easy to do through the React tab, we're going to see that add profile is where we are calling setState. So this add profile node is what's being re-rendered. App is not being re-rendered at all. So an important performance consideration, even though it wouldn't matter in an app such as this, is we could have taken this state here and managed it inside of our app component, say placed it in here, and like input, name, bio, etc., and then pass that down as properties into add profile, and then had handle name call setState in the parent. And often that's a very good pattern. But for state that's changing so regularly inside of an input form, every time we type, that would cause a re-rendering of the entire app, which is usually insufficient for most use cases. So in this case, even though in general it is a nice pattern having that circular data flow, we are going to isolate the state further down the tree. Also, if we wanted to input default values here, we could have just set them in the state, and then that would act as a default value inside of here. So going through and finishing this off though, let's go ahead and create inputs for each one of these. We're also going to have a handle bio, handle hobby, let's go ahead and bind those like we did with handle name. We're going to write similar code inside of here. Just going to copy it. But instead of name, here we're going to change bio. Instead of name here, we're going to do hobby. Something else I want to show is that if we look at each of these values being rendered out, take note that even though I've already mentioned this, it wasn't clear earlier, inside setState for each of these, it's not overriding the original object, it's doing that merge. So right here, for example, as I'm typing in a new name, since I didn't specify a bio and a hobby field, it is leaving those states alone. See how only one of these is changing and it's not shutting these other ones out to blank? So the last thing we need to do is we need to give a way to submit this text to the parent component. You can do this through a submit event or through an input on click. Either or is fine. I'm going to do it through a click. Don't need the event in this case, but I'll go ahead and put it in case I need it later. And we're still going to have this button, just move down here, that when clicked is going to add the user. But this time, instead of adding that hard-coded user, recall that if we go back up here to add user, we're no longer going to put in this hard-coded user. We're actually going to create a user object based on the states of the input boxes up here in our add profile component. So in our handle click, we're going to say let new profile be equal to name, this.state.name, bio. Should I call it the right thing? Yep. This.state.bio. And hobbies is going to be a little bit different. That one's expected to be an array. So we're going to give it an array with one element being this.state.hobby. We're going to take this object and we're going to pass it in to this.props.add user new profile. And what that's going to do is that's going to come up to here, but instead of doing it this way, we're going to delete that. Add user is now going to take a new profile and we're going to concat it to the original one, which when this is done, will trigger a re-render in our list of profiles. One more change that we need to make is that currently this button is still bound to this.props.add user, which isn't going to work quite right because we need to go through that new handle click function we created, which is going to pull the information out of our component state. So let's go up to here and bind it like all of our other methods. That way it has the right context inside the callback. We get rid of this now too. And changes, it's not on the props, it's on the instance. New person, new bio, hobby, hit add. And there we have it. With that, we can now accept more complex inputs into our React application. Ideally, you should have as many stateless components as possible. And to further encourage this, React gives you a shortcut when creating these stateless components. They're often known as functional stateless components. They can be made with a much cleaner syntax. So recall with arrow functions that if there is a one-liner, you can emit the return. So you can use something like var my function is equal to something like that. So what we can do is we can create a component without using the class keyword this time, because since it has no state, it has no methods, these functional stateless components will only contain a render method. So whenever you have a component that looks like this, with nothing but a render method inside, this is a great candidate for a stateless component. Let's say inside here we just had the p props.hello or whatever we passed into it. So a way that we could convert this to a functional stateless component is by saying var my component is equal to like so. A couple things to notice about this. So one, since this is a stateless component and does not really extend React.component, it's not going to have a this value. So alternatively, props is just going to be passed in as the one and only argument for this component. So instead of this.props. Whatever you need, it's just going to be props. A second thing is we can omit the return keyword because technically speaking, while this isn't really a one-liner, it is a one expression statement, just one long React expression surrounded by these parentheses. So the fact that we're just using parentheses here and no correlation, no return, that's just that we can omit the return since it is a one expression arrow function. And then in it, we're just going to render out our stuff like usual. So for example, we could say div, I am a functional component. Need that. Comp is not defined. Let's go down here. So we're just going to take this and render it out like usual. And looking over at our page, you see I'm a functional component right here. And if we wanted to, we can pass it props and consume them same as always. Well, not quite same as always. It's going to be props dot instead of this dot props dot. Didn't follow my own advice over there. We must leave out this because it's simply passed in through the props argument. And there we have it. So if we take our current app, let's look at which components we can convert to these functional components. Well, our main app component has quite a bit of state in it, so it's not a good candidate. Additionally, add profile is managing state for its inputs, so it is also not a good candidate for this. But our profile component is, so let's go ahead and convert it. This one's not going to look quite as clean as the other one because we have to do some setup right here. So this isn't a one expression statement, but we could turn it into one by dropping this map in line over here, which this is part of the reason why map is so popular in React, is that it allows you to utilize these functional components better. So just so I can get rid of this setup code up here, I'm going to go ahead and say, instead of hobbies down here, I'm going to say props.hobbies.map hobby to. Also notice with this JSX that we can go back and forth between expressions in JS and expressions. Where here we have JSX and expression, and within that expression we have more JSX, in which we have another expression. The JSX compiler is smart, and it's pretty common to go back and forth flowing between the two. Let's go ahead and delete this, get rid of the return, get rid of that extra parenthesis, take this back a level. We need to get rid of all of the thises. Get rid of this as well. Try to run it. Not working quite yet. Let's export this a little bit differently. We can also export after creation. So let's go ahead and do export default profile. There's other ways to do it, but this is the cleaner one in this scenario. Additionally, we're missing a parenthesis right here. This parenthesis match there, that curly match there. And we're in business. Back to how it works before. And whenever possible, to sum it all up, if you don't have any states in your component, it is worthwhile to use functional components instead, as they are easier to debug in many cases and a much more concise syntax. Initially, we were hard coding all of the profiles inside the state of our application. And while this works great for mocking and demoing things out, typically we'd be reading this in through an API or some other sort of service. So next, let's take a look at how we would change our React application to dynamically read these profiles in from a server. So to begin with, I have a server running on localhost 3000 that for the profiles endpoint, got another curl there, that for the profiles endpoint, it's going to give me a JSON array that is identical to what we were originally putting inside of our getInitialState for our app. So let's change it to, instead of hardcoding there, to grab it from this API. So first off, we're going to clear this out from here, and we're going to have it right there. So it could be tempting to try to set this state up right here inside of the constructor, so to fetch the data in and do it right there. But we can't do that, and we shouldn't do that. And the reason for that is, recall that data fetching is an asynchronous operation. So if we were to do that, it actually wouldn't get populated until later on. So the best place to do this is inside the component didMount lifecycle method. Component didMount is a lifecycle method that is a hook that we ran as soon as this particular component is rendered onto the DOM. Not before, not after. So let's go ahead and add that component didMount. And it is recommended to put all data fetching and component initialization code when working with APIs inside of component didMount. Also notice that we're still going to have profiles equal to a blank array. We're not going to just leave it like that, because the problem is if we have it here, those different instance methods inside of our components, where they attempted to render that out, they're going to break down like we see over here. This .state.profiles is undefined. Furthermore, if we were to set this to null, that's also likely going to break things because in this case, it's not going to be able to map properly. So it is common to set this up with an array still or some sort of valid data type because keep in mind that our app is going to entirely render once. So it's going to run this entire render method and all subcomponents render methods before this component did mount is going to get executed. Because the flow here is it will all get rendered, component did mount will be evaluated, we're going to fetch in the data, we're going to change state and re-render the component. So we have to set this up so that it can render with or without that data being read in, hence why we put it like here. Now you can use whatever sort of data fetching library you want. If desired, you could be using jQuery or SuperAgent, or there's lots of different ones. Well, one of the ones that I like using and that the React community has been gravitating towards is Fetch. Fetch is ES6 native, when we discussed it earlier. It's a little bit of a friendlier way to work with things other than raw XHR requests. So we're going to use Fetch to bring in our API. So we're going to say fetch at HTTP localhost 3000/profiles. Also recall that Fetch is promise-based. So we're going to say .then to response.json, .then data, and this should contain our array. Let's verify. Now let's go over to our browser and verify it worked. First off, note that there's only add new profile here because we haven't actually set state yet. So currently our application state for profiles is empty. This will still work like before though. And looking at our console, we'll see that we have two objects, which is what we're logging out right here. And those contain our profile objects that we loaded in from our server. An important point to watch out for is often we'll have different servers serving up our API and our React app. Two requirements must take place. Either the same server must serve up both the API and your React app, or you have to make sure to enable cores on your web server. The problem is by default, JavaScript cannot send AJAX requests to servers that it did not originate from. It can only do this if the server has enabled cross-origin resource sharing, commonly known as CORS. That's a problem that you will see on, the bug will show up in the front end, but has to be fixed on the back end. So that can be a little bit confusing. And really quick, just to show you what that looks like, I'm gonna go to my little server. I wrote an express over here. I'm going to disable CORS for one moment. Restart the server. So when I disable CORS, if we reload this and check out the console, we're going to see that cross-origin request blocked. The same origin policy disallows read and the remote resource at. So whenever you see this, you either need to change your backend to enable CORS, or whoever does run your backend, ask them to. Additionally, it's another reason why it's a good idea to always put a catch block for your promises. This can help us out in instances of both CORS, or if we try to hit our server while it isn't running. That error is catching us there, but we also don't want our app to break down when the server is not running at all. We'll log out that error. And there we go. We will get that error from our catch block. So that said, let's kick the server off and have it running with CORS. Make sure that's running. And we're back to get our object over here. Then what we want to do inside of our code is inside that component did mount, we want to say not log out, but this dot set state. We're inside object. And now all of our data is loading, but this time instead of being hard coded within our React application, it's being dynamically brought from our server. And I just want to point out that this is in fact rendering twice. Once without the data, then once again after the component did mount and resets the state. So to add that into there. See, we have app rendered once right here and app rendered again right here. While going through this video, some of you might have been seeing this warning unique key issue pop up. This isn't something that will affect the correctness of your React application, but it will affect the performance. Later on in our performance tuning section, we will be detailing how to deal with this issue and why it occurs. But back to the task at hand. So while this code is functional, something that's unideal is that we should take this Ajax code, remove it from the component, and put it in its own separate utility library. The benefit behind this are, well, there's a couple of them. One is we can later on, say, mock this out when testing this component, because as is, this component is tightly coupled to this Ajax request, which would make it very difficult to unit test. Another benefit of taking this Ajax and separating out into its own utility module is if we had multiple components that were interested in interacting with this process, we could more easily share that behavior between them. And we're also going to see something called higher order components, where we could actually wrap this component did mount logic with this fetching inside multiple components, sort of like a mix-in. So let's do that next. Let's take this and separate out into utilities. And also when we work with stuff like Flux and Redux and work with bigger projects, it's very common you have a utility library that does all of your API interaction. So going back out to here, let's go into app and make a new directory called utils. I'm gonna touch profile API.js. You could make it a JSX file if you wanted to, but we're not actually going to be writing any JSX code inside of it, so .js is fine. We're going to go up to our component. We're going to take this, and there's a couple different ways you can set this up. If you wanted to, you could make it a constructor function with instances of your API. If you want to do this in a more object-oriented sense, you could just make it a library full of utility functions that all interact with it. I'm just going to make top-level functions for it, but feel free to make this more object-oriented if it's useful for your application. And I'm going to say export function get profiles. I'm also going to make an endpoint constant. Yank the skin in a moment. Again, take this fetch, delete it from there. Send this out right. Frequently, we'll be hitting multiple endpoints through this. Like, for example, we're not going to do it right now in this particular video series, but we could also implement posts through this. So we might want to say post profiles and be able to recycle some of that logic in URL. But for now, we're just going to swap this out with endpoint. One other part is we're going to make our API helper promise-based as well. So this isn't actually going to set the state, because now with this set state inside of here, before we had the problem where our component was tightly coupled to the Ajax request, now this Ajax code will be tightly coupled to the component. So we're actually going to return a promise and utilize that promise inside of our component to set the state. So instead of resolving the second promise, we're actually going to go ahead and return the promise from here. And then we're going to do two things. One, we're going to import get profiles. Notice I use the curlies here, and that's because I did not make this a default export, and I didn't make a default export because I anticipate adding more helper methods for this API at a later time. From utils. Then what we'll do is down here, component did mount, we're going to say get profiles. This will return a promise. So we can call, because that's what we're spitting out right here, is a promise dot then profiles. We'll say, like before, this dot set state profiles to profiles. And now we have a much more modular and testable version of consuming our API. React provides various lifecycle methods that will be called at various times in the component's, lifecycle. There is component did mount, which will be called after the component mounts, component will mount, which is called beforehand, and there's other ones that aren't used quite as frequently that are useful, such as component will receive props, component will receive state. Later on, we'll be seeing how we can use component should update in order to do some performance tuning. But for now, let's look at component did mount and components will mount, to the most useful and frequently used ones. So let's open up our usual index.jsx file. We have a pretty typical hello world sort of setup in here. And what we're going to do is we're going to add some new methods to it. These methods will act as hooks and be called automatically by React, such as component will mount and components did mount. Kind of sort of like overriding these from the base React component inside of our app component. What's going to happen is will mount will trigger before our component gets rendered into the DOM. Because recall, for all of this React with the virtual DOM, natural DOM, what's going to happen is everything's getting put inside this div ID app, and this will get called before it shows up in there. This will get called after, and in between them, the render function will be called. Keep that in there to verify that. And going back over here to our console, we'll see component will mount fired in render, and component did mount will fire next. We'll also see that as we update our state, the component's going to stay mounted. That's not actually going to be something that unmounts our component. So if we go down here and we create a button, for example, create a state change function here, and in there say this dot set state to something else. We're only going to have that in there for a moment anyway. Equals this dot state change dot bind this. And notice when we hit this, render gets triggered again, but the component doesn't actually remount again. So a more practical use for component will mount and component did mount is sometimes we'll set up initial state inside component will mount, but if we're doing it through Ajax, it should really go in component did mount. The reason for that is if it goes in here, we want everything to finish loading up, have it render once, and then reload it again. So typically speaking, we'll see Ajax initial state setups go inside component did mount, not inside component will mount or inside our initial state. But something that will also go in component did mount is some sort of functionality such as hooking into a Flux store, as we'll see later on, or if we want to do something like have a set interval. So for example, if we wanted to have this count update every 500 or so, we can say set interval. We're going to have an arrow function bind our this context like so, 500. And when that happens, we're going to say this dot set state count is equal to our old count. So it's kind of weird. Usually our constructor comes first. And we don't need that anymore. This dot state dot count plus 1. Let's go ahead and get rid of that and say count. This will be updated. And then inside component will unmount. Getting rid of that. I want to have that set to 1 there and naturally increment it to 1 over here. And see how periodically this count is being incremented. Now, if we want to do some cleanup action, get rid of that set interval once the component has unmounted, what we can do is, just so we have something to point at it with, we're going to get a periodic function right here. And instead of pointing to an anonymous function right here, we're going to have this say just these contents right here. Pass in this dot periodic dot bind this, and then clear interval. This dot, actually let me do it this way. We usually do this dot periodic is equal to this dot periodic dot bind this. Sometimes if you're only using the method once, it could be worthwhile just bind it there instead of up here. But since we're going to use it twice, go ahead and do it up there, like so. And then have it clear interval there when it pops off. Same as before, but now with valid cleanup logic. Frequently in our React components, we'll pass data down from a parent component to a child component through setting attributes in the child component. And this is similar in HTML tags that we can set stuff on a particular tag through its attributes. But in HTML tags, we'll often set data on the content or the thing in between the opening tag and the closing tag. While we haven't really been doing that so far, we can do this with our React custom components as well. Let's take a look at how to do this. So what we can do is any content here, let's say we have my component. So far we've just been making these self-closing, but we can in fact create an official opening tag and closing tag like so, and pass arbitrary content in there. This is known as the children, right, just like in HTML, of this particular component, and it's actually passed in as a property and can be accessed through this.props.children. Really, it's a property just like setting it through attributes is, but it lives on a different spot under children, and we pass it in a different way, which is occasionally useful. So looking at implementing the rest of this, we can say class my component extends react.component. And this right here, this arbitrary content, it will be available on this.props.children, like so. Got to add the return here. And see how this content was rendered inside that. Furthermore, looking through the React tab, same results. So in addition to just text content, we can post other React custom components inside of there. So we can say class, another component. And so this, we'll go ahead and say like so. And while here we only went one level deep, we could have wanted to go arbitrary levels deep and pass in information through both attributes and the content like we did here. Frequently you'll have behavior in one component that you want to share with another component. And you could replicate it, but that's not giving good code reuse. And the proper way to deal with these cross-cutting concerns is with higher order components. Initially in React, people will deal with these with mixins, but since moving on to ES6 class notation, which don't currently provide any sort of mixin facility, the current state of the art is do it through these higher order components. At a high level, a higher order component is going to be a function that takes in a component and it passes it into a different component class that's going to create some methods and render that initial component passed in. So it's going to kind of act as a wrapper. And the way that we're going to achieve reuse through it is we're going to generate wrap version of these components where all of them have that, those same outer methods. So with no further ado, let's take a look. So what we're going to do is we're going to create a generator function, basically. So let HOC_gen for higher order component generator equals something that's going to take in a component and it's going to go to an anonymous class, which will extend react.component like so. And first off, in its render function, it is going to render that component. So this is basics of the pattern. This function is going to take this component in, go to this class, and render the component side of it. But the way to really utilize this is we're going to have some sort of method that each component passed into this is going to share. There's lots of different ways we can utilize this, but as an example, let's take that idea before where we had a set interval, and now any component that we pass into this higher order component generator is going to have a set interval such that every 500, it's going to update that internal count. So setting up super props dot state equal to count 0 and component did mount. And we're going to see this pattern a lot where our higher order components are going to be component lifecycle methods that we share between our components. For example, in Flux apps or Redux apps, this will often be where we connect to our store. So in component did mount, we're going to go ahead and say set interval, this dot set state count is equal to this dot state dot count plus 1. Save that. And then the place where we can use that splat operator that we talked in ES6 is we can pass all of the state passed into this higher order component and all the props down into the inner component through the splat operator by going like this and do the same thing for state. And you can utilize this outside of higher order components as well, but this is one of the primary places to use it. And then what's going to happen is we're going to make a regular component. We'll just call it component 1, comp1 for short. And inside its render function, we're going to go ahead and say comp1, and we're going to render out this dot props dot count, which is going to be passed down to it from here in the higher order component when it generates it. And we're going to wrap this by saying let wrapped comp1 equals gen comp1. And we're going to render this one instead of this one, so that way we run these bits first. Then going down into our app, we're going to be doing multiple things here, so we'll go ahead and put inside of a div. So, slight bug, unexpected token at line 19. Going over to line 19, we're missing a parenthesis for the set interval. Put that in and reload. Good to go there. So it's going to pass this down into there. Now let's actually use it inside of there. So this component right here is going to have this count passed down into it. So we can render it like so. It's not actually changing because we didn't pass interval to our set interval. Now it's running like before. So this isn't really too much different from what we had earlier, but now let's share this functionality with another component called component 2, where we can say, let's copy this, say component 2, again, we're going to wrap it and create an instance of it down there. Now we both have two components with the same component did mount behavior, but we can take this up a level and make it even more interesting yet by passing each of them a different initial starting value here. So since this is a higher component, we're going to do it a little bit differently than we usually do. Instead of passing it in as an attribute, we're going to pass in the initial state of the component through when we generate it. So let's start this one at 0. Start this one at 100. Then what we're going to do is we're going to change this to, in addition to taking a component, taking an initial state. And instead of saying it there, we're going to say this dot state is equal to state. And now see we have this one started at 0 and this one started at 100. And we can continue to make more components this way. And again, even though here we used it for this use case, anytime you have any sort of cross-cutting concerns between your components, higher order components are the proper mechanism with which to share that functionality. As we frequently pass down properties from a parent to a child, frequently is useful to document what properties that child component expects. We can do this through a facility called prop types. When using prop types, it's kind of like we're adding static typing to our React components. So let's check it out. So inside our usual startup boilerplate, if we say class my component extends React.component like so. And let's say that our component is going to render out two things. It's going to render out a name and account, like so. And when creating an instance of it, we'll say my component and count is to 4. Okay, so add in the extra curly. And see we have bill and count equals 4. Make this a little bit more readable for us, new line. But the important part is that clearly this component expects to be passed a name and a count in order to work. And if we were to leave one of those out, it will not work as expected. So the way that we can document that is with prop types. And we set those on the component itself by saying myComponents.propTypes. And we set that equal to an object. And if we look at the documentation, we'll see that there's a variety of different ones we can use, where this is the property, and this is what we're saying about it. So for an optional array that we expect to pass on, we do a React.propTypes.array. In our case, we're expecting a number and a string. So we're going to say name React.propTypes.number and count React.propTypes. Want this to be a string actually, and this one to be a number. So far, this is really nothing more than a comment, essentially because it doesn't actually change anything. Now, what could change it is if after one of these we chain is required. So for example, if count was always required to be there, we can go ahead and add .is required. These are kind of sort of like database validations for those who've done any sort of back-end programming. See, here's all the ones for optional and all the ones for required. Capital R over there. And if we go through and run this again, it's still going to work. It's not going to crash down, but in the console, React is going to throw a warning that it was expected. And when you deploy React to run production, all these warnings are turned off for efficiency, but it can be useful in development. Additionally, if we would have passed in the wrong property type in here, like for example, I said I expected a string here, and if I would have passed it a number in for the name, it'll also give me a warning for that. So let's go ahead and pass count equal to 4 to make that error go away. And here we'll do name equals 10. And we'll see that we get a different warning where warning failed prop types, invalid prop name, type number supplied, expected string. Now lastly, as kind of a supplement to prop types, there's also something called default props. And default props are kind of like an ES6 default argument. And in the absence of that property being supplied, it will override that value with this default argument. So if we go down here and we say myComponents.defaultProps is equal to, and let's just say we want to define a default name of Joe, we can say name Joe. And whenever we fail to supply a name property down here, it will put Joe in its place, as we can see here. Again, this is a very powerful feature. All the stuff you would expect to see in database validations are here. If you look through docs, you see that you can even supply your own custom functions to run it through. And when working with yourself on a small React application, often these won't really provide much value. But when working on these with a bigger team, the documentation these provide and the validation will prove invaluable. Typically speaking, you don't ever want to do any sort of explicit DOM selection or manipulation in React applications. You want to rely on the one-way data flow, but occasionally it can be useful to do this traditional more jQuery document.get by ID style selection with React. And let's take a look at how to do that in one particular use case for it. Let's look at the code. So what we want to happen is we have an input box and a submit button. And we want it to be that whenever we hit submit, it's going to both clear this out and it's going to autofocus. So I hit here, notice that autofocus me back over to here for each time. And we're going to do this through reactdom.findDom node. That's kind of the React back hatch for this. And looking up the code, we'll see that we created an input with a value and an on change. This is very similar to what we've seen earlier, where we have state with input. This is a controlled component. And as we are setting state through typing, it's just going to be resetting the state up here, modifying our input. And then in our submit, we're emptying it out like before, but then we're also having this callback function run after we do it. And the way this is working is there's a special property called ref. This ref will allow the parent component to reach down into the child component through the property refs. So since we set this as input box on our parent component, it will have a property called this.refs.inputBox where it can reach this through reactdom.findDom node. And that's what we did right here. We said react dom.find dom node, this.refs.input box, and then we hit the focus property on it, very jQuery-like. And this is important because render doesn't return any references we can use to grab this. So this is really the only way to do this in a React idiomatic way. We could sit an ID here and go in through, jQuery or something, but that's not really as beneficial. This fits a little bit more cleanly into the React paradigm. But again, this is an escape hatch. You shouldn't rely on it unless you really need to. So earlier, we left this out for simplicity, but recall in our section about how React handles DOM reconciliation, there is this concept of children being passed keys from the parent that can be used to determine if it needs to be reordered, shifted, instead of it just being naively destroyed and recreated unnecessarily. And if you look at some of the code we made earlier, such as this one here, inspect element console, you'll see that we've been getting this warning for a while, and we kind of been ignoring it for now. And if you go to the page it links to, it gives a pretty good explanation of what's happening, but let me explain a little bit more simply. Basically, we need to supply a key attribute for each element that has siblings. That way React can efficiently update these. From a performance standpoint is where it usually matters. Correctness, not typically. Sometimes with some very dynamic children it will. But for bigger sites, this can become a serious performance issue, and those console warnings can be kind of annoying. So let's take care of it. So if we go into our app component, and we see down here where we are creating the profile, there's a couple different ways we can handle this. One way we can do it is we can say key is equal to, and with map, if you supply a second parameter to the anonymous function, that parameter will be the index. So for 0, 1, 2, 3, so on and so forth. And we can simply say that key is equal to that index, like so. Reload, check our console again. And we still have a warning, but that's for our profile. We got rid of the warning where it was occurring on the app level. So let's see if I get rid of this over here. Now I have 2 warnings. So we made one of those go away. Another way that you could do this is often when bringing in this information from an API, it'll have an ID attribute. Pretty commonly, it will have this. And instead of doing this with map, we can go back to having just profile and say key is equal to profile.id, which we can see here is unique across our profiles. And really that's all that matters, is that this is unique across every sibling. It doesn't have to be globally unique, as mentioned earlier. Go back here and see the warning is taken care of again. And typically when something is loaded in from an API, you're probably going to use metadata or data inside of those objects to determine it. But when we make our own, we'll make strictly our own view parts that aren't related to a database, such as we did in here for this list li elements aren't going to have any sort of key from a database. Here we're going to have to fall back to our prior technique of saying index, like so. And now both warnings have gone away. And even though we recycled the index or the key 0 here, and up here in the app, it won't matter because it is unique across siblings. Next, let's take a look at how to further tweak our performance by selectively determining whether a component should re-render. So while you shouldn't rely upon it, except in circumstances where it's truly necessary, React does provide you with an escape hatch for opting out of a component re-render. It is a lifecycle method called shouldComponentUpdate, and when called, it will return true or false, and you will run some logic to determine this. And based on that result, it will re-render or not re-render that component selectively. This can be very useful for when you have a component here that is regularly getting re-rendered and an expensive component over here that you really don't want to re-render unless it's truly necessary. In the context of our app that we're doing, I wouldn't actually use this. It'd be a little bit overkill. It'd be micro-optimization. But let's see how it works so that way you can apply it to your large applications. So first going into the app, what I'm going to do is I'm going to, for each profile we render up here, currently it's re-rendering every profile every time we add a profile. So for example, if I go into the profile component right here, inside the render method, I'm going to say console.log profile rendered. Going over into here, if I bring up the console, we'll see that profile rendered 2 times, right? So each one of these got rendered once. Then when I add a new profile, we're going to see profile rendered 3 times. This function here is going to get called 3 times because recall that each one of these profiles, if we go up level to app, is a child of the app component, and the state for the profiles is being maintained here in the app component. So when we added a new profile, we recalled setState here, triggering a re-render here, which recursively will trigger a re-render for each of our child components. And again, in this case, I don't think this is a problem, but let's say that it was very expensive to re-render a profile, and we didn't want to re-render the profiles that we aren't changing. We only want to render the new profile and leave the other 2 alone. So the way we can achieve this is going back over here to profile. There's a lifecycle method called shouldComponentUpdate. It'll take in next props and next state. And what those are is on this re-render of the component, what the next props would be and what the next state would be are passed down here. And what we can do is we can compare those to the current props and or the current state and determine whether we truly want to re-render. So the proper way to do this, the most extensive way to do this would be, all right, this has the properties name, age, and bio. So we're going to want to say if this.props.name is not equal to nextprops.name, return true. We should re-render. Additionally, if this.props.age is not equal to nextprops.age, we should re-render. And finally, if bio is different, we should also re-render. Now the thing to keep in mind is that this shouldComponentUpdate method is going to be frequently called. So if you have complex logic in here, that complex logic will frequently run, and it could be potentially more expensive to run this shouldComponentUpdate method than it would have been to simply update your component. And given the whole reason that we're opting into this shouldComponentUpdate is to be as efficient as possible, we should put the minimal amount of logic possible in here. And in our case, these profiles are immutable. You know, there's no option to update them after the fact. There's no reason to check name, age, and bio. We can just check one of those things, and that'll let us know if the entire one is the same since they're immutable. So to make this a little bit more minimal, I'm going to say return nextprops.age or name, doesn't matter which one we use, is not equal to this.props.name, like so. What we're going to see here is that we're going to see profile rendered twice for the initial 2 profiles being rendered. Then when we hit the add profile button, that new profile is going to render, but the old profiles that we already had there will not be rendered. So come back over here, reload the page. Inspect the element, we see profile rendered twice. Now when we hit add, profile rendered only once because we didn't re-render the other 2 profiles.
There are many different ways to style your applications in React, and one of the first ones we're going to look at is inline styles. Now, many of you have probably grown up learning that inline styles are the worst thing ever. And in React, it's not quite so simple. There are some definite disadvantages to inline styles, but I encourage you to open your mind up a little bit to the concept because a lot of the initial disadvantages of the inline styles are not the case with React. The reason behind this is inline styles are really more of an implementation detail of how we're applying the styling. It's not really the same, oh, here's a style that lives exactly like the with the element. We can still achieve separation of concerns if you so wish. The inline styles is just an implementation detail. With that in mind, I have createreactapp bootstrapped up in here. There are some CSS files in here, but we are going to ignore them for now. As such, I'm going to get rid of this CSS right here. I'm going to blow this away. And we're just going to create a simple Hello World app. And what you can do is you can create a JavaScript object, because who hasn't thought themselves in the past that CSS looks kind of similar to JavaScript objects? And in that object, your object properties are your CSS properties and the values are the values. So we can say border solid, color blue. The couple of gotchas here is one, since this is objects and not CSS, we have to separate these with commas and not semicolons. Another one is that we do have to put the quotes around these strings. And then the final one is if we're using something that is typically hyphenated, such as border style, right? We cannot have hyphens in JavaScript property names. So whenever you want to use a CSS property that is hyphenated, you instead have to flip it to a camel case style like so. Then what we do is inside here, we say style equal styles. And there we have it. Can inspect it, we can see the applied styles right there and inside of there. I'm going to leave that running in another tab. And first thing to note is you might be saying, well, what about reuse? Well, even though we applied this with an inline style, and it is common to, with React, bundle up our styling with our components. One of the reasons for this is one of the biggest challenges when working with CSS is actually the cascading nature of CSS, right? Where if you have a change that's applied up here and it's affecting something that's happening down here, it can be really hard to keep track of that. So inline styles are actually useful for keeping things locally scoped, and it's kind of the approach that motivated CSS modules, which is a little bit more robust of approach to the same general technique. But just to get the creativity flowing, to show you some possibilities with this, if we wanted to, we can even make a touch styles.js file over here, just to show you how we could get some reuse with this if we wanted to. And there's nothing stopping us from taking this, pasting it in there, right, exporting it and requiring it down inside of here. That could be a good way to get reusable styles. That being said, the reason why I don't think this is the best approach, it has nothing to do with the implementation detail of it being inline style. It's because it is not possible to achieve pseudo selectors with this. So if you want hover state or anything like that, this won't be in luck. So given that, let's take a look at a couple of other approaches to style our React applications. Next, let's explore using traditional style sheets for your React application, as well as how we can use these style sheets in a little bit more modular manner. So I have a freshly booted createreactapp application here. And in here, what we can do is index.js imports the CSS file. And even though the file is imported here, it's really available everywhere. So what we can do, if we want to, is we can open up this index.css file, and we could really treat this as just our traditional, styles.css file, and put styling for the entire application in here, some class, some ID, and we can do this whole thing like it's 1999 if we really felt like it. Now, in my opinion, that's kind of missing the point a little bit. A part of the reason people like React so much is because of its modular emphasis, right? We have components with all of their dependencies and all of their everything co-located with them in one spot, so we can reuse them other places. So if a component only contains its HTML and we have 3 nice little bundles of HTML, but their styling is kind of dangling between all 3 of them, we're not going to get as powerful of reuse capabilities as we would if the CSS was more specific to the component. So a way we can do this a little bit better, and this is kind of the approach advocated by createreactapp, is for every component, we can create a CSS file, right? And again, these are going to be globally loaded, which has some issues, but at least lets us know what's intended for what. We can go into app.js, and we can also open up app.css. I'm going to clear this out a little bit. And one difference is, in HTML, we can say div class equals. However, we are not actually writing HTML, right? We're writing JSX. Class is a JavaScript keyword. So when writing JSX, instead of the class, use class name. It will compile down to class. So here we have a class name of app, which is going to use this styling right here. And I'll make it a little bit different. I'll make a class called primary. Call this one primary. And I'm just going to say a typical border solid, color blue. And one immediate advantage of this over the inline styles that we looked at in the last section is we are using true CSS style sheets here, meaning we can feel free to use pseudo selectors in here. Also, since we're writing an actual CSS file, all of our usual CSS validation tools will work, right? Any tooling that you have for normal CSS will apply here. Gonna load this up in our tab. Actually, I have it loaded up on this tab, come to think of it. Oops, forgot to actually save my React file. Let me do that one more time. Let's get this running for real. Style with CSS, great. Now, one problem with this approach is it gives the illusion of modularity without giving us actual modularity, and I'll show you what I mean there. So let's say that we have a component.js, just some arbitrary component we're making. We're going to import, I'll call something different, call it widget. Okay, let's import widget from widget. Don't need that, don't need that, don't need that. Probably would actually use a functional component for one this simple, but we'll roll with it. Okay, so this is also going to have the class name of primary. I'm going to call it my widget. And we'll see the issue I was talking about. See how both the widget and the outer component have the same styling? Even though, when we look in here, it appears that this CSS belongs only with this component, right? But it's actually applying globally like it would with a typical CSS file. The good news is with some slight configuration change, we could turn this into a CSS module where the CSS loaded in here will only apply to this file. Let's check that out in the next section. Next, we're going to look at how we can make things modular even at the CSS level with CSS modules. So rather than a concrete technology, CSS modules is an approach to CSS where via tooling, you have CSS that only applies locally, right? No global cascading, just here's a component, here's a CSS for that component. Can't be simpler. This is nice because as soon as too many people start jumping the style sheet and there's too much cascade, you just start throwing at import everywhere and things more or less fall apart without the most rigorous of style and discipline. With CSS modules, that kind of relieves you of some of that discipline and offloads it to the tooling. A little bit more background on it is if you've ever done Beam style CSS, CSS modules is basically Beam implemented with tooling, right? Where we have CSS that applies to very specific things. I'm sure that is an oversimplification of the topic, but it will suffice for today. And what we did here, I have a create React app that I've configured to use CSS modules. Unfortunately, you do have to eject in order to get that. I'll show you what changes I had to make in order to get that ejection and make things working. But what we did here is if I go into source, we'll see I have an app component right here. And the first change is instead of just simply importing styles like we did before, what we're going to do is we are going to import it into a variable called styles. And instead of setting class name to a string, I like doing it like this way. Set it to styles.x, where the value of styles.x is a class x, right? The name x doesn't really matter here. I'm just using this as a placeholder. But see, we have a class that applies a border of solid and a color of blue. And we can now reuse this class name, be it x, primary. You could even go back to using, just straight up HTML selectors, right? Usually something like just div would be way too simplistic. It would clutter up the namespace way too much. But with CSS modules, you can use the names that semantically make sense to you in the moment and not have to worry so much about cluttering up the namespace. Okay, so that being said, see how I also load in another component called comp and render it. And if I hop over to that component, we'll see that it also imports its own styles from its own CSS sheet, styles.x. And if we open up that CSS sheet right here, we'll see that we have a class called X with a color of red, right? So we have two different class X's loaded up in two different spots. Let's see the results. And voila, we have two different components, both with a class name and a CSS sheet that we set to X, but we have red and blue. Well, how did this happen if they both have the same class name? Well, if we open up the inspector and we take a look at these elements, we'll see that the class name that actually applied is app __x __ 7w8y6. And this one has the prefix 1GWQ9, right? We can also see that down here, right? Both of these have X in the class name, but our tool chain on our behalf added a unique prefix to it. And it also added, the component part before it. This is great because with the tooling automatically making these unique for us, we can reuse the name, but the tooling will add this extra stuff to it to make it, in effect, locally scoped for us. So you could do this yourself, right? That's kind of what Beam's about, just adding, extra stuff onto it so each class name is unique. But it's really nice having the tooling do this for you. And it's not a hard configuration to change. So the way that I did this was I ejected the app. And if you go into the config and you go into Webpack config dev, you can do the same thing to prod. Go down to CSS. And here's the magic right here. We set modules equal to true. And here's the name, right? Where we put that little hash at the end, right? That random hash generated for us. Not random hash, but hash generated for us. The local name, and then the name of the component, right? That mirrors just what we saw over here, getting us CSS modules. And if we pop over into this fresh React vanilla app I created here, I can npm run eject, That's really the only downside to this, is that you do have to eject. There are some techniques that involve using an alternative forked version of Create React script that are getting popular. And additionally, there are discussions amongst the Create React team to maybe at some point in the future include CSS modules. But for now, this is the trade-off, right? Like most things in text, there's trade-off to every approach. The trade-off to this one is you do have to stray off the standard path a little bit. I think it's worth it though. Okay, so now we have this config file. Let's open it up. And here we have it right here. Here's the original version. Here's the updated version. All we had to do was add that module's true over this one and set the prefix, or sorry, set the local name over to here. And with that, you have CSS modules for your Create React app applications. Well, there are many different libraries that can help us author CSS with React. One popular choice is style.jsx, and some benefits of it are it gives us full CSS support as well as server rendering and easy configuration. For starters, the way you bring it into a project is you just npm install save style.jsx. I already have it in here inside my package.json. Style.jsx. And Style.jsx actually works as a Babel plugin. So in order to use it, unfortunately, you will have to eject your Create React app. But the configuration of it is a little bit simpler. We can go into package.json, and there are two different ways Babel can be configured. One, it can be configured through a Babel RC file. And another way is we can actually have a Babel section inside of our package.json. And we'll see here, by default, it'll have just had this when you eject, but I've added in a section, plugins, style.jsx/Babel. Okay. Now there's a couple different ways to use it, but one way I enjoy using it is like this, where if I go into app.js, at the bottom of all of our stuff, we can have a tag called style. This is kind of similar to the old style scoped, for those of you who are familiar with it. Style.jsx, and we can apply some styling here. Select the p tag, color equals red. And we can give that a run. Class names are fine as well. You can also define it inside a different JavaScript sheet and import it in. There are also plugins for various editors to work with that little style section. For example, I know they have some great Vim and Atom plugins for doing so. So the tooling support is there for it. And there we have it, testing 1, 2, 3. Right, we see over here, it did the CSS module stuff where it applied extra stuff in it. It's not just a simple div selector. And that's gonna give us similar isolation to as we saw with our manual CSS modules. Thank you for watching React.js. I hope you enjoyed this video. Thank you for watching React.js. I hope you enjoyed this video. Thank you for watching React.js. I hope you enjoyed this video. Thank you for watching React.js. I hope you enjoyed this video.